Well, welcome back for week 3. So today we're really going to dive into the lean mindset and try to understand a little more about what it really takes to be able to see processes, to see quality, to see productivity from a lean perspective and a lean viewpoint. And I will tell you that this perspective, as I've mentioned before, is different than the way that most of us were brought up thinking about quality and thinking about productivity. And so some of it's going to be a little different. And so we're going to try some different strategies for helping you to be able to understand this. As with all of the class material, really the best way to fully understand the material that we're getting ready to present is to immerse yourself in kind of forcing yourself to think in this way and be able to look at your own processes in this way. So one of the key terms that we're going to be talking about in today's class is waste, waste and value added, and making a determination of the differences between those two. And so as you encounter personal processes through your week, I'm going to just encourage you to look for what is value creating, and then what is waste according to our definitions that we're using in this class. And if you do so in a critical manner, I think you may be surprised at some of the things that you see in your processes. So after the last class session, I'll often have students that ask me, well, I'm working at a company, maybe I'm in an internship or have a job, and I know that my managers are not practicing or not using a lean mindset, and already I'm seeing the benefits of adopting a lean mindset, as we discussed in last class. What do I do here? What can I do to make my boss think lean? And honestly, there really is nothing that you can do to influence your boss other than you yourself having a lean mindset and having that sense of excellence that we're talking about from last class, and then also from this class that we're about to encounter. So the best thing you can do is just practice these yourself. The other question students will ask is, well, when I'm managing groups of people, or if I'm responsible for supervising groups of people, how can I persuade them to adopt my ideas? How can I get them to see processes from my perspective? And I want you to remember, as we talked about last class, that you're not telling other people to adopt your way of thinking, and you're not directing, finding solutions and then telling the people that work for you that they need to adopt your solutions that you've come up with. The idea here is that you empower the people that are working for you, teach them to be able to see waste, for instance, as we're talking about today, show them different examples of this, and give them the opportunities to see waste for themselves and practice. The idea is to try to get everyone in the organization to be looking at their processes with lean eyes, be able to see, for instance, the waste that we're talking about in the lectures today. Well, I'll tell you one way to do that is with video, and we are using some video in some of the application assignments that are due throughout the semester. So you're going to have the opportunity to create video for yourself and be able to see yourself in different processes that you're a part of. This is increasingly becoming a really valuable tool for managers in businesses, using video and having workers video themselves doing processes and then watching themselves. And I'll tell you, it's always very eye-opening to see yourself interacting with a process. And so video is a really powerful tool. A lot of times you don't even need lean tools or lean techniques to find improvements by just watching a video. So I wanted to start out today with a video. Now this is a comedian guy, British comedian guy, Mr. Bean. And I don't know how many of you find Mr. Bean to be funny, but it's a short little video of him doing a process. And so I want you to watch this video. We'll do a little bit of discussion afterward, but then really the point of the first half of today's lecture video is all about being able to see a process such as Mr. Bean's and identify what is really creating value and then what is not. All right, so let's enjoy watching this. Well, I hope that some of you enjoyed that. Not everybody is a fan of Mr. Bean. I know it kind of takes a unique sense of humor, but that really does. It gives an example of a process that we're able to watch using video. And so as you're thinking about this, as you were watching that video, You probably, if I asked you, said, hey, I'd like you to give Mr. Bean some advice about painting his room, take a look at his process, and tell me, some things that you would suggest to make his process better. I'm sure that you could watch that video, and as you were watching, you may have even been thinking of ways that Mr. Bean could have done this differently, or thought to yourself, well, that was just dumb how he did that. Why didn't he do it differently? That just seems really silly. And I'll tell you too, I suspect that if we were to sit down with Mr. Bean and show him the video of himself painting the room, that he himself would be able to recognize some ways to improve a process. So, here's one tool. It's a tool that's being used in companies today, and it's just taking video of a process and watching it. So that's a really simple way of really beginning to evaluate processes, look at them, and figure out what are some ways we could reconfigure this to make it better. So I'll just give you that. In your jobs, sometimes you can just take a video of people that are working with you, or take video of yourself, or take video of a process, and then you don't have to do the evaluation. You can just show this to line operators or the people that are actually doing the work and say, here's a video of you doing the work. You figure out what are some ways of making this process better. In fact, let me challenge you. Even now, you can, in your kitchen, when you are cooking a meal or preparing a meal for yourself, and it doesn't matter if that meal is, really complicated, like a multiple ingredients and different types of cooking processes, or if it's just as simple as microwaving some leftovers. Watch yourself. So set up your camera, set up the video camera on your phone. You don't have to show anybody else. Just hook that thing up and look at yourself. Have that take a video of you as you prepare the entire meal from beginning to end, from when you walk into the kitchen until you're sitting down and actually eating, and then watch yourself. And this is even before I've really given you any real good tools for improving processes. I suspect that just watching yourself do a process, that you will see ways that you can improve. And these could be things that you have never seen before. You didn't even realize that you were doing it. And now as you watch yourself, you realize there are some real ways of improving this process, making it better, making it more consistent, making the process easier, or making the time duration shorter. So I'll just encourage you to do that. Of course, in today's talk, we are really going to go into detail about how you look at a process such as Mr. Bean's from a lean viewpoint and identify what is waste and what is value added. And at the end of today, you will definitely be able to come back to this video and be able to determine from a lean perspective and a lean viewpoint what we consider waste and what is value added. So how do we define waste? It all goes back to the definitions that we covered early on in the course. So remember, the reason that we have processes is processes create value for our customer. Okay, remembering these definitions? Okay, process creates value for our customer. We defined a process. A process is an input or a set of inputs, those inputs being transformed into some output. The transformed output, those inputs that are transformed into output, that output then is what creates value for our customers. So the way we define value added in our process, what creates value in our process, is that when we have inputs, when those inputs are being transformed, we consider that to be value added. So we've got this variety of inputs. If those inputs are being changed, manipulated, combined, okay? When we are taking those inputs and we are actively, meaningfully changing the input into an output, that transformation that's in the middle, when that transformation is happening, that is value added. Everything else in the process that we do, and we might do a ton of other things in the process other than manipulating those inputs, everything else that we do in a process we consider non-value added. Does that make sense? Like just from a definition standpoint, okay? Because I'm trying to create value for my customer. So when I'm transforming the inputs into an output, it's value added. When I'm not transforming inputs into an output, I'm not doing things that are creating value, not doing things that are value added, okay? Now in the textbook, I think in the Lean Six Sigma Memory Jogger, maybe in the Lean Handbook as well, they define 3 ways of dealing with tasks. They say a task can be value added, okay? So value added, you can imagine a value added task is something we would want to keep, right? Because we want our work to be value added, okay? Value added you want to keep. Then they define something called non-value added, right? So if I'm doing, one way to improve a process is if I identify something that is not creating value, that's useless, right? If I see I'm doing something that's useless, what's one way to improve the process? Stop doing the useless stuff. Okay, right? Does that make sense? Okay, so non-value added. They have a third category that they call necessary non-value added, which would be things that it technically isn't turning an input into an output, but you know what? We just got to do it. Okay, it's just necessary. And I'm going to tell you that for the purposes of this class, and that's the way a lot of people define it, but the purposes of this class and companies that I've been a part of practicing lean, what we will do is we do not have three categories, we only have two. We either say a task is value added, creating value, or it's non-value added, not creating value. And when it's non-value added, we do not determine whether or not it's necessary. We just label it as non-value added. The reason for that is the way to improve a process is that you work on reducing the non-value added stuff. And so the more things I can get on the list over here, that's more things that I can work on, okay? And I want more opportunities to improve. If I label something as necessary but non-value added, I've kind of put it into this special bucket where I ignore it, and then I don't have the opportunity to improve it because I'm not going to be creatively looking at it, all right? So we will not, for this class, I will not distinguish between necessary or not necessary. I'm just going to say it's either value added, creating value, or not value added, not creating value. Throughout the course, I will be introducing you to some vocabulary that comes from Lean. You do not need to be able to speak Japanese to be able to do Lean or understand Lean, but there are some words, because Lean originated at Toyota in Japan, there are some words that originate from the Japanese that here in the United States, as we are discussing issues, processes, we use this vocabulary here in the United States, people that are in the Lean community, and I want you to understand these so that when you're on interviews or in jobs, you can speak you can speak using that particular vocabulary. And so here's a few of them. So the first one is Muri. Muri is overburden. This is the first type of waste. So it's not one of the classic 7. I guess I should clarify since I introduced it a little early. The classic 7 is considered muda waste, and this is where we will be focusing most of our time. But oftentimes it's said that Muri and Mura create muda. They create that muda waste. So Muri is the overburden. So this is where you're asking people to do more than they're capable of doing, or to work faster than they're capable of working, or reasonably able to work. So you know how this works. Like if you need to cook a meal for the family, and your family makes you, they say we're all in a rush, and you need to cook it really, really fast, and you start working on cooking that meal, and you go really fast. If you work faster than you're really capable of working, what's going to happen to the quality? Quality is going to go down, okay? Same thing happens, you probably recognize this Muri overburden about, you've been in school long enough, like about midway through the semester, I don't know, 2/3 of the way through the semester. You know that part of the semester where it seems like all the professors are ganging up on you, where they're all giving their exams like on the same day, plus you have like 3 projects that are due, and you've worked on them a little bit, but there's a lot of work left on them, and you've got more work to do than you can reasonably get done in that period of time. So you're doing things like pulling all-nighters and rushing through things and scrapping together to get all this done because you got all these exams and projects. You know what I'm talking about there? That's this waste of Muri. When that happens, what happens to your grades on those tests and assignments? Your grades go down, right? Your grades go down where you don't perform as well as if you had time to prepare for those things. So that's this waste of Muri. Mura is unevenness. So Mura is when you're asked to do one thing and you're tracking along and you're doing great on that one task, and then someone pulls you away from that and sends you to another task to do something different. And then you're working on that and doing fine, and then they pull you away from that and send you to something else. And it's like, just let me get in a roll. You know how it works. Like, if I can just get in a groove doing this one thing, then I can get some productivity. I can get some momentum going. But if you start switching me around from thing to thing to thing, it reduces my productivity. It reduces my quality. And that's just that waste of Mura. this is why we typically will like to batch work together, where it's like, look, I just want to do a whole lot of this one thing before I go to a whole lot of this next thing, because it minimizes that downtime, that non-productive switching that I'll have to do, okay? And that's typically why we do that, is to reduce that waste of Mura. Now, I'll just give you a preview. In Lean, we know that our customers want variety. They want a variety of different things. They don't want big batches of this and big batches of that. They want a little bit of this, a little bit of this, a little bit of this, and a little bit of this. But that creates this Mura, this unevenness. And so what we do is we try to create predictable variability in Lean. Now, this class, I can't go into details about it. It's a principle called level loading in Lean, and we can't get into all the mechanisms of it. But essentially what it is if I have to do task A, task B, and task C, and there's variability in doing those, what I'll do is I'll set it up so that, for instance, I'll do 3 A's and then 1 B and 2 C's, and then 3 A's, 1 B, and 2 C's, and 3 A's and 1 B and 2 C's, so that I have the variability in my process, but the variability is predictable, so that the switches from each one to the others is more predictable, so I can actually lower my non-productive time, make that process more efficient by having a repeatable pattern that gives me the variation, but the pattern is repeatable, so the pattern gives me that evenness. But that's something for a different class, or something you can read through on your own. But what we're going to be talking about mostly is muda waste, and really the key to Lean is being able to recognize when this waste is happening, when muda waste is occurring. If we can see that waste, if we can learn to see it, then we will be incentivized, we'll be motivated to go and try to find ways of creatively removing that waste. Okay, so how do you improve processes? How do you find ways of removing the non-value added? So this is important for you. You must, process improvement is different than probably a lot of the classes that you've taken at Bauer, in that you don't do process improvement inside of a computer or inside of your office. So you don't collect data and put it into an Excel spreadsheet and then run some manipulation and click solver, and then your spreadsheet model tells you how to improve a process. Improving processes happen in the middle of where that process happens, which is called the gemba. Okay, so, and again, this terminology, I'm sharing this with you, and I want you to know it for the exam, because these are terms that we actually use often. Not every company uses them, but many companies, if someone's been practicing Lean, they'll definitely understand what gemba is, where the gemba is. So what all gemba means is, it just means where the work happens. The only way to improve a process is by being in the middle of where the work happens, not in your office, but where that actual physical value-added transformation is occurring. That's where you make the improvement. And that's where you can figure out what the improvement is. Now you can go, like Mr. Bean's process, you can go there and you can watch Mr. Bean, and that technically, that's sort of being around the gemba, but the best way to improve a process is by experiencing what's called Genchi Genbutsu. That means, it's a terminology that means getting your hands dirty. It says get your hands dirty. Don't just be at the process, be in the middle of the process, in the middle of everything that's happening, actually experiencing it for yourself. Process improvement is very experiential. In order to improve a process best, you have to be in the middle of where that work happens, actually doing it yourself. This is why the process operator, the person that is actually physically doing the work that you're trying to improve, is probably the best person to actually make that improvement, to be able to see and feel and touch that waste. This is a principle, being in the Gemba and Genchi Genbutsu, are principles that I think for most of you will probably be a valuable, something valuable to sort of keep in your back pocket as you get into your first job. So I'll kind of explain why. A big reason for it is that most all of you are young. You look young, okay, and then you go into these jobs, and you're going to be supervising, managing people that are a lot older than you. And this happened when I got out of college. I got my college degree, started working in manufacturing, and immediately started supervising people that were older than me. But see, I had a college degree. they either had a high school diploma or not a high school diploma at all, not even high school educated, and they were working at this plant. I was supervising them. So obviously, I am smarter and more talented than they are, and they should just listen to whatever I have to say. I should just be able to tell them whatever I want them to do, and they should just do it because I'm a better person because I got the degree, okay? And the thing is, you get into these processes, and the people that are working for you, they're going to look at you, and they're going to say, I have been working at this process, working on this machine, doing this exact same work for 15, 20, 25 years. And I have been working, every time I see a way to improve this process and make it better, I work to try to make it better because it makes my life better if I can make this better. They've been working on improving this process, and now you're going to come in, especially after taking this class, and you're going to say, I can make your job 50% better. And you're there with your khakis and your polo, right? And they're going to look at you and say, no, you're not. And not only will they say not believe you, but they won't believe. They're going to think, oh yeah, you came from college. The way that you're going to help me make my job 50% faster is you're going to make me work harder. You're going to make me work harder, faster. It's not going to be as fun. It's not going to be as easy, and you're going to make things more difficult on me. That's why you're here, is to make my life worse. And they won't believe you, okay? And in fact, anything that you try to do, they're going to try to dismantle and make sure that it doesn't happen properly because you are not their friend in this process. So going to the Gemba and Genchi Genbutsu can be a tool for you. What I mean by that is you go up to a process operator and you say, hey, I'd love to be able to learn your job. Will you show me how you do what you do? Can I try it? And you jump in and you try to do what they do. And when you are in the middle of doing what it is that they do, you are going to experience all kinds of things that you can't see. So you're going to be trying to put two things together. And you're going to say, well, you told me to put these two things together, but they don't go together. And they'll say, well, right, you have to manipulate it, and you have to squeeze this part this way because they never fit together exactly right. You got to kind of work at it. And you go and you're like, well, this hurts my hands. And they're like, that's part of the job. You're like, well, I don't like this. And they say, well, I don't either, okay? And then you can ask them, so you're experiencing what they experience. You're starting to get some empathy. This is a hard job. I'm getting tired. You do this all the time. How do you do this? Okay, it's starting to build some empathy. You ask them, you say, well, have you ever thought about different ways to improve? What are some things that, do you see any ways that you can improve this? And they're going to say to you, yeah. They said, I've been asking my boss for like months. I've been saying I need a little tool pouch to like keep stuff in so it's right there with me. And my boss won't buy that for me. And you're sitting there and you've experienced what this person deals with, and you say, well, you're right. You need a tool pouch. Let me go get you a tool pouch. I'll get it for you. I'm going to get that for you. And then you go find a way of getting them a tool pouch. All of a sudden, you're their friend. You're helping to make their job easier. You're helping to make their work easier. They see you as someone that empathizes with them and someone that is not looking to make their job harder, looking to make their job easier, which really is what Lean is all about. It's about making the work easier, not harder. But you've got to build that level of trust, and being in the Gemba is a great way to do that. So that's really a first step to doing this. So let's take a look at waste, okay? Now for this next slide, you're just going to have to take part of this on faith. I have a demonstration. I'll actually show it to you. But first, let's talk about it kind of philosophically. Okay. Most people will say that a typical process, this is one where we haven't evaluated the process through Lean Eyes. Most processes are 95% waste. That's what most people say. I will tell you, most Lean practitioners will actually push that. I will as well. Most processes that you'll encounter are actually probably more like 99% waste. And that's not a misprint or a misquote. I really do mean like only 5% of work that happens is actually creating value. 95% of the work that people do is non-value added. When a company has been practicing Lean, working at reducing waste for years and years and years, companies like Toyota that maybe have been doing it for 25 or 30 years, maybe they get the level of waste down to 80% waste, 20% value added. This would be world class. And I'm just telling you, if you were to ever see a process that was only 80% waste, your jaw would drop and your eyes would bug out. And you'd say, oh my gosh, that is like amazing. I can't believe that that's going on, because you would see so little waste in that process, and it would be amazing to you, okay? So this is very, very hard to achieve, this world-class level. Now, you don't have to believe me right now. I know that there's implications around this, and that is that, you think about the jobs that you've had where someone has been paying you to work, and your boss has told you, hey, I want you to do this job or that job or whatever. And there's a lot of the jobs that you've had where you've worked really, really hard. Okay, and some of you had like physical labor jobs where, I mean, it was like physically draining to do this particular job. And here I am, I'm telling you that 95, 99% of what you were doing didn't create any value at all. Okay? And things like, you have a process, for instance, for getting ready in the morning, okay, where there's this transformation that you're trying to make occur, and you know how long that process takes. That's why you set your alarm clock, because you know, I've got to wake up by this time in order to have my body transform to leave the house by this time, right, to get out, and I need that much time. And what I'm telling you is that 95% of what you do in that process is waste and actually not helping you to transform to get out of the door. And you're saying, well, are you kidding me? Like, I've got this process down. It only takes me 10 minutes. Roll out of bed, boom, and I'm done. Still, 95% of probably what you do is actually waste. So this is kind of hard to conceive of. So for right now, I'm going to explain why that is and how that is. But for now, let's just say, what if it's true, okay? So just say, Dr. Miller's crazy, but what if it's true, okay? So here's our process. Here's a process time, okay? This total bar represents the total time it takes to do the whole process. And I'm saying that this much is non-value added, and that little bit up there, that is the value added piece up there. Now, if I told you, just like for most things with lean, when we're trying to improve processes, a good benchmark for improvement is 50%, okay? With lean, we look at a process and we say, how can we make it twice as fast, okay? And so if I look at this process and I say, I want you to find a way of reducing the time it takes in half, where are you going to focus your attention in this process for improvement? Are you going to focus on the value added and try to make the value added faster? Or are you going to focus on the non-value added and try to shrink this bar? Where are you going to focus your attention to try to reduce the time it takes to do that process?
Non-value added.
The non-value added, right? Because there's more opportunity to improve by looking at the non-value added. And in fact, that's what we do in lean. In lean, when we're looking at the processes, if we're doing something value added, we do not want to mess with it. We just want to leave the value added the way it is. What we want, there's so much non-value added, we focus our attention there. We try to get rid of it, or we try to shrink it, the non-value added, because this is where our biggest opportunity is. But with a mass production mindset, they don't do that. Mass production manager does the exact opposite. So a mass production manager will do these things. We'll say, well, we aren't doing enough value added, so let's make people work overtime. Okay, we're going to make people work overtime to do more value added. What happens to our cost when we do that?
Increases.
Costs go up, okay? Or we'll say, we'll just make employees work faster. We'll say, well, we're not creating enough value added. Okay, employees, speed it up. Start working faster. What's going to happen to quality?
Go down.
It's going to go down. You know what's going to happen to the culture, right? Going to go down, right? We'll say, well, we aren't doing enough value added. We need to hire more people. We just don't have enough people. What's happening to cost? Cost going up, hiring more people. Or worse, we'll say, let's buy some expensive automation. Let's buy a robot, some piece of equipment, some technology, some computer application, whatever that is, to automate this whole thing, so that we can do it faster. But the problem with that is this automation that we bought is automating the whole process. We are actually paying lots of money for technology to do our non-value added. We're still doing the non-value added, it's just that we have bought some expensive piece of technology to do all of our non-value added. There's still very little value added that's happening in those processes. So the key really is to attack the non-value added activities in that process. So I want to show you a process so that you can understand how a process could have 99% waste in it, all right? So I brought a Gemba to the class. Usually I'll do it through video, which isn't as good, but this Gemba, you brought it into class so you can see it here. So here's our process. I've got this foam board, okay? And what I'm going to have the customer wants us to make these things for them. And what it is it's this foam board, and I'm going to put a screw in the center of this board. So it's 6 inches square, so 3 inches from each side. Screw needs to go directly in the center, exactly perpendicular to the surface of the thing, and the head of the screw needs to be 1.25 inches above the surface of this, okay? Now, I don't know what the customer needs that for, but that's the customer specification. That's what they want, so we're creating that for them. So I have some inputs to this process. I have the foam block, and I have a screw. Those are my inputs. The output to the process is the foam block with the screw inside of it, straight up and down, in the center, 1.25 inches off the top. Does that make sense? I've got my inputs, I've got my output. Now we define value added as when my inputs are being transformed into my outputs. So if my inputs are the foam block and a screw, what activity in this, when will we recognize that there's value added going on with our strict definition of value added? What's value added in this process? When the screw goes into the block, that is value added. If I pick up the screw and I wave it around like this, is that value added? No, that's not value added, okay? If I take the block and I take the screw and I sort of like hold them next to each other, is that value added? No, the only thing in this process that's value added is when the screw is physically being married to the block, when they are physically being connected together and the screw is going into the block, that is value added. Everything else in the process, non-value added. Okay, and we'll be able to see that happen. We'll be able to see what's value added and what's not, all right? So, so we're going to do this process. We're going to time it. We're going to measure how long it takes. Before I do that, I want to give you a tour of our manufacturing facility so that you know your way around, okay? So up here, we have, this is the production station where the worker works. Here's the inventory of the blocks, okay, that we've got, and then we're going to put the screws in the blocks, okay? Now, we keep our materials in different places. Now, I'm going to let you know, the first demonstration, this is mass production mindset organization, okay? So I'm going to describe where the things are, but I'm going to use like sarcasm in here. And I want you to hear, this is not lean. This is me trying to translate to you what a mass production mindset is like and what results from a mass production mindset, okay? So first, let me go over here. Over on this wall, I want you to imagine this is a wall with a racking system that has all of our fasteners and small parts for our company are all in this one location. Okay, now here's the sarcasm, right? So this is why we have it all here. We have vendor managed inventory. Our suppliers come in. They know exactly where to go. They have to go to one spot. They don't have to look all over the plant to see where all these fasteners and things, small parts are. The other thing is that all of our employees, excuse me, when our employees need a fastener or a small item, you know, there's one place to go. You go to the parts rack. So they go to the parts rack, you take your part number, you match your part number up with the part, you know, whatever it is, and then you pull some out, and then you got it, okay? And this is where you get all the small parts. Is that okay? Okay, so that's our parts rack. All right. Next part is over here. Anyone, while I'm walking over there, anyone in here ever worked manufacturing? Okay, cool. Are you the only one? There, another one, anyone else? And someone here, cool. Anyone else? 3 manufacturing folks, okay, and me too. Okay, so up here, what we have up here, now the first class wasn't familiar with this, so I'm gonna be interested to see it. Actually, someone was, but it took some getting to before they said it. Up here is the tool crib. Any manufacturing folks, you know what a tool crib is or no? And if not, it's okay. You do? You know what a tool crib is? Do you mind?
No, I think I do.
Okay, cool. Do you mind sharing a little bit?
Just a centralized location where they keep the tools.
Where they keep the tools. Awesome. And this happens in a manufacturing plant when you have really expensive tools. Okay, now again, you're going to hear me talk mass production mindset. Okay, this is not lean manager, this is mass production manager. So here's the deal. What we do is we have a central location where you keep the tools, same as the small parts. If you need a tool, you can go here. This way we have a less inventory of tools, and we can just, you know, have people, when they need a tool, they go here. But the thing is, these are expensive tools we pay for. And here's the deal with all the employees that we hire. I mean, the employees, they are uneducated. And honestly, you know, they're just here to get a paycheck, and they're a bunch of thieves. So if we just leave our tools laying around the party, you're on your head, right? Am I right about this, right?
Even nitro gloves.
Yeah, gloves. These things, these gloves, you say, well, what about gloves? But these nitrile gloves that are chemical resistant, I mean, they'd be like $50 for a pair of gloves, okay? And they'll take them. Our employees, they are such thieves. They're going to take these things. They'll sell them on the black market. Like they'll take them out in the street and they're going to sell them and make money off of them. They're freaking lifting this stuff away from our company, right, and making money off of it. So we got to protect that stuff. So what we do, now listen, if I'm the manager and all I think is that my employees are dumb and thieves and just here to get a paycheck and I better keep my eye on them and police them or they're going to like run off with my stuff, what do you think that's going to do to the culture? What do you think they're going to start acting like?
Fear.
Oh, I start acting like thieves, okay? You know, because I'm projecting that on them, right? Okay, so but what we're going to do is we're going to protect that stuff. We're going to keep it safe. When you need a tool, you bring your ID, you get your ID scanned, and then you get the tool, and when you bring it back, you know, it scans again, because we'll take it out of your paycheck. You take this thing, okay? Because I'm not going to trust you. I don't trust you. Does that make sense? Okay? So you get to be the tool crib manager. Isn't that awesome? That sounds like a great job. Okay? The thing about being the tool crib manager is when you're a tool crib manager, you come to work, and guess where you get to work? In the tool crib, which literally is a cage. Usually in the middle, am I right about this? Usually chain link fence, am I lying? Chain link fence, locked doors. You get to essentially go to work and go to jail. You get yourself in and you're locked in jail, and there's this little slot and someone comes up, excuse me, I'd like to get the hammer, you know, and you're like, okay, you know, and you scan it out. That's the way that works. We have our tools here. And I got a screwdriver and I got this fancy thing that's like, it's like a level, and it's got the level, and it's got a ruler, and it's like a square. It's like 3 tools in one, and I actually paid extra for this thing because I could have bought just a ruler and just a square, just a level, that would have been cheaper overall. But then we would have had to inventory 3 different items. This way, I can make my tool crib much more efficient by just having one more expensive tool that's like the 3-in-1.
Don't be cribbing from the tool crib.
All right, so here we go. So, and keep in mind, that's all mass production mindset, okay? That's what we're dealing with. Is that okay? That's what we're doing? So let's see how long this process takes. Let's see what it's all about. Now, I also want to demonstrate for you, I just want to let you know, I am the best worker at this plant. I am the fastest, most precise, most skilled worker in this plant, and I'm going to show you that I can do this process faster than anybody. You come in here, you tell me that you're going to make this job faster, I'm going to show you. You ain't making this job faster because I'm already as fast as it gets. So I need somebody to help me with your iPhone or whatever. Swipe up from the bottom, click on the little stopwatch. Someone time me because I'm going to show you how fast I am. Who's going to time me? Awesome. Okay, yep. Which one of you? Down here in front? Is that okay? And then that way I can keep my eye on you, can tell me what to do. Okay, so you just say on your mark, get set, go, and then I'm going to start the process. We'll see how long it takes. Okay, hold on, let me get ready.
On your marks,
Okay.
get set, go.
Okay, I'm gonna come over here to the rack, and I'm gonna look around for the screws that I, part number, there they are right here. Okay, got them. And then I'm gonna go over to the tool crib. Okay, here we go. I need the screwdriver and I need the little 3-part thingy. Is that scan that in? Yeah, give that back to me. I don't need you to go and let you be due for all that. Okay, got it? Got it down here. And over here. Okay, now I get this. Okay, and then I gotta take this apart. Okay. 3 inches from the side. You guys are making me nervous with all watching me. Okay, I think I got it. Okay. Oh, that's no good. Too far. Okay. Good. What do we got? 2 minutes, 12 seconds. Okay, so that's 60, 72. Let's see. 120 plus 12, 132. Is that right? 132 seconds. Awesome. Wasn't that awesome? Was I fast or what? All right. Do you want your workers working that fast?
No.
Why not?
Well, first of all, it's a hazard. They can fall.
It's a
one
hazard. There's a
place to
safety.
another.
Yep, safety. What else?
Quality.
Quality. Okay, their quality is going to be less when they're working that fast. Anything else?
They're
Time
productive.
consuming when you get to the, you keep running back and forth, so time consuming.
Yeah, so you saw some of that waste that was in that process, right? The other part is, like, I can keep that pace up for a demo to show you how fast I am. I am not going to be able to do that all day long, right? And we got to have this worker available to do this all day. We need a repeatable process. So here's what we're going to do. I've got this new process, and and two, in there, what was value added?
The last part when you
What was the only part value added?
actually screw in it.
When the screwdriver is going down, now I don't know if you know how the screwdriver works, but you like screw it in, then I had to readjust my hand to screw in again. When I'm doing the readjustment, is that value added? No. Only the screwing down, not value added. Screwing down, not value added. Screwing down, only the screwing in. Everything else that I did, non-value added. I mean, very easily 99% not value added, okay? So we're gonna do this process again, except this time what I've done is I've built a little fixture. I don't even need this fancy tool anymore, okay? I've got a place for my screwdriver. It's labeled screwdriver there. I've got my screws. They're already here, and they're all oriented the same direction, okay? And I've got this block. I've got this little fixture. I just built this out of like scrap wood in the garage. And what you do is you slide this in here, and then when you take a screw, you put it here. There's a little corner. This corner is located 3 inches from each side. There's a little flat edge that's straight up and down, so I don't have to figure out if it's up and down, okay? And when I screw this thing in, how high do you think this part is? 1.25 inches. So as soon as the head gets down there to the board, I'm done, okay? And so we're gonna see how that process works. One last thing that I wanted to ask, what was I doing in this process? What was like all the looking and the maneuvering and the measuring and what was all that about? What was I doing? I was checking. What was I checking for? The accuracy. I was checking the measurement. I was checking to make sure that I was making it the way the customer wanted it made. Right? Do you know what we call that in manufacturing? Like there's a fancy word for it. It begins with I. Does anyone know? It's an inspection. That's an inspection. I was inspecting my work, right? I was inspecting the quality to make sure that it was right. Okay? So let's talk about this. What was value added in the process? When I'm pushing the screw in. What about the inspection? When I'm inspecting it, is that value added or non-value added?
Non-value added.
It's non-value added. Technically, according to our process, it's non-value added. Okay, well, if the inspection's non-value added, then should I walk into this process, you brand new graduate from UH, should I walk in to this process and say, hey, Dr. Miller said the inspection's not value added, so stop doing the inspections. Should I stop doing the inspection?
No.
No, why?
Because this is a necessary non-value add.
It's necessary for the way I have the process currently. Remember, processes are inputs transformed into outputs, and every process is perfectly designed to turn those inputs into the outputs that you get. And right now, my process is perfectly designed to give me defective products. And so if I have a process that's perfectly designed to give me defects, I better inspect the work to make sure that those defects don't get to customers, because otherwise, we're going to go out of business. My customers won't have that. Does that make sense? If you have a process that is perfectly designed to give you defects, then you'd better have an inspection. The key is, you'll see with this process, if you have a process that you've built that doesn't need that is perfectly designed to turn inputs into a perfect output where there are no defects, then you don't need an inspection. Okay, if you have no defects, you need no inspection. As an example, for most of you, there may be some of you, but for most of you do not, in the morning before you leave or school, go to your roommate or your family or whoever and say, hey, I've got this process, this complicated process, where I have to get my shoes tied, and I just want to make sure. You inspect my shoes, make sure they're tied all right. Is this one tied all right? Can you inspect my shoe? Do I need to do an inspection because I want to have perfect quality here? You don't do that because you already have a process that is perfectly designed and reliable to tie your shoes. You don't have to wonder, did I tie my shoes? Because you've got a process that does not create defects. Okay, so if you have a process that doesn't create defects, you don't need an inspection. All right, well, so let's see this again. I think I showed you this whole thing. Let's see how long this takes. You ready to time me again? All right, so here's my process. I'm the new process operator. Okay, now we're going to trust the operator with the screwdriver. We've got visual management, so honestly, anyone can walk in and see whether the screwdriver is there or not. It's labeled, so even if it wasn't there, we would know where it was, or we would know that it was missing. If it's laying around, we know where it goes. Okay, all these things. Let's see how long this one takes. Okay.
Ready,
Yes.
set, go. Go.
Oh, okay. Yeah, sure. Sorry. Yeah, it's fine. I'm good. So we'll slide this in here. We get out a screw, right? Put this here. Put it up that way it's straight up and down. And then I can just screw this in here until the head gets down to the blocks, and I'll know, ooh, came undone. What do you know? And then, and then I know that it's the right height. Pull it. Done.
24 seconds.
24 seconds. Okay, 24 seconds. Thank you very much. Okay, so let's see how long this takes. Let's see, 132 minus 24 is 108 divided by 132 is, that's an 81.8% improvement in time there, okay? And notice I didn't spend, I spent a little money on this fixture. I actually saved some money because I'm not using these, all right? And then in this process, am I working really hard at that? No. This job is so much easier. This job is a lot slower. This is what we call, this is the principle that we use in Lean that we say, where we say, you must go slow in order to go fast. I'm going to go slow. What happens to quality when I slow down? Quality is going to improve. So now I'm doing this job slowly. I'm paying attention. I'm able to get higher quality output. I'm not doing as many non-value added activities that are in there. I'm able to get the job done 81, 82% faster, spend almost no money, quality is going up, and you're really drastically reducing time. Do you have a comment, question?
What about using a drill? I
Ah.
understand
Yeah.
there has to be quality, but a drill
Sure.
is faster.
So what if we use like a power screwdriver? Okay, so, and I could, what we say in Lean is we're gonna look for the no cost or low cost alternatives first. So when we get a power drill, what we're doing there is we're trying to do the value added faster. Does that make sense? Power drill is focused here to do this faster. All right? So if power drill was my only thing, well, believe me, power drill is a lot more expensive than this. We're keeping it in the tool crib for sure, okay? I'm still going to the different places, getting the stuff, and then I'm going like this. And I don't know how much that's really going to save on quality, because with a power drill, I'm still going to have to get the height right. I don't know if you've ever tried to do a power screwdriver, but like it goes so fast, like how am I going to, I'm still probably going to have to get out the screwdriver. Now I'll have an extra tool, okay? Now, I'm not saying that we would never use a power screwdriver, because I could use a power screwdriver in this, and wouldn't I save some time? I might save a second or two, okay, on this, but what I'm saying is I can get an 81, 82% improvement and spend zero money on automation and technology. And this might be good enough for the customer. I might be able to get the, 81% improvement. We were making money before, we're really making money now, and I didn't have to buy a power screwdriver. I'm not saying we would never buy technology. I'm just saying that's our last resort in Lean. We're going to use our minds. We're going to use our creativity first. Because usually buying expensive technology, what that ends up doing, it makes the process more expensive. Now I have to have somebody that maintains the power screwdrivers, plug in the batteries for them. They're more valuable, they're going to break. The screwdriver's not going to break. Does this make sense? Okay? And I'm not saying we never would. I'm just saying a last resort. I want in your mind, part of Lean is thinking creative improvements first, not technology improvements first. Shoot, for that matter, why don't we just buy a, $300,000 robot that does this all automatically? We just program it and it does it. Oh, that would be even better. But then, what if the customer tomorrow, remember, organism viewpoint, what if the customer tomorrow decides this isn't what they want? Now they want something different. Now they want the screw in the side, or they want a different screw. Well, then we just bought this $300,000 robot, and the customer's going to go do that to us? Whereas if we have a person that's doing this 81%, 82% faster, it's pretty easy for a person to make that adjustment, not so easy for a robot. Does that make sense? Okay, and again, there's plenty of robots at Toyota, all right? I'm not saying that, that Lean's doesn't have any robots. I'm just saying we use our creativity first. If we can get by with creativity, we're gonna do that first.
Almost everything we do is total waste. 98% of what we do is total waste. The waste is everywhere. The best story I could tell you on this is Toyota's BT2 project. So when Toyota was revered as best in the world, and back in, I think it was almost 2000, and everyone was just going, oh my gosh, Toyota's incredible. The president of Toyota said, we're gonna cut everything in half and double capacity. If Toyota is saying that, and they are 1,000, 10,000 times better than FastCap and everybody else in the US, there's just no comparison. Could you imagine how much fat we have? The fat and waste is everywhere.
Before the end of the semester, you probably will think I'm crazy looking for waste in my processes and looking for even improving 1 second, 2 seconds of waste. This is Paul Akers saying this, the voiceover, and he has this principle called 2-second lean where he tells all of his workers, he just says, look, find a way to improve your process just a little bit every day. 1-2 seconds a day, make a small improvement in your process. That's all I'm looking for. Not, it doesn't have to be these 81% improvements. It could be little, small improvements. The thing is, if you can get everyone in a business to be making very small, little incremental improvements on a regular basis every day, it builds into very, very large results when everyone is doing this. Toyota says at their Camry plant, one of their Camry plants, they say if every worker were to come up with a way of saving 1 second in their process, just 1 second, every worker, they could build 8 more Camrys per shift they could build. That's a lot of productivity just based on 1 second per worker every day. Instead of saying, you can reframe the question. Instead of saying, why would someone be so crazy as to work really hard and obsess over saving just 1 second? Aren't you doing a lot of work just to save 1 little second? It just doesn't seem to make much sense. If you flip the question and think about it differently, why would someone want to knowingly waste 1 second? If you've got something productive where you can be, making a difference in your life or someone else's, why would you want to just knowingly, just waste 1 second if you know it's there? If you know that opportunity is there, wouldn't you want to get rid of that? That's more of the mentality of lean in saving time. So these are the 7 wastes and the brief definition of them, so you can kind of see them here. I'm going to walk through each one so you can understand what it's all about. Here's an acronym that's commonly used for them. I think there's other acronyms for them, ways to memorize them online. You will need to know these for the exam, but if you just think about how processes run, oftentimes you can kind of derive what they are. And so, that's why I have this slide here. And I mentioned here that that there's an 8th waste that companies often discuss. And then some companies will list more than 8 or more than 7. But the companies that you're going to go to, these will be the 7 that most people will understand and know about. Okay, so let's talk through each one. And here's and I'll probably have this slide up a couple of different times during the class because I don't want you to get confused by this. The key to improving processes using lean, one of the keys, is being able to see the waste. So I want you to be able to recognize that this is waste in the process, and this is waste, and this is waste. If you see the waste, then you can start to use your mind, your creativity, to figure out how to get rid of that waste. There's not like one magic lean tool that gets rid of all the waste. Remember, Toyota's been working at it for years, and they've gotten some of their processes down to 80% waste. So there's not one magic way of getting rid of all the waste. You have to use your creativity, you have to use your mind. But in order to do that, in order to improve, you've got to be able to see what is wasteful in that process. And that's really what I'm trying to get you to do. Just because you see it doesn't mean you should blindly get rid of it. Just like, we recognize that the inspection here is waste. Don't go into your first job and see the line of inspectors at the end of that process and say to your boss, hey, my professor said that inspections are waste. We should just fire all these people. Okay? Same thing, we're going to see here, one of the wastes is inventory. So don't go to your first job and see the big, multi-acre warehouse that's, 5, 6 stories tall, filled with all kinds of inventory next to the plant, and tell your boss, hey, the first thing I want to do here is tear down the warehouse. No more warehouse because inventory is waste, right? Because you'll get fired. Because companies can't exist without inventory. You have to have it. I just want you to recognize that it's a waste. So here's the first waste, overproduction. Overproduction is the first of the waste that's often seen as the worst of all the waste because overproduction causes all of the other waste to happen, typically. And it's usually the first waste that happens. Overproduction is when you buy or make more than the customer needs before the customer needs it. The customer has something that they need, but in anticipation of that need, you buy or make it ahead of when it's actually needed. So this is where we're like producing on a machine in high quantities. We've got, we'll have buckets of parts, 1 bucket or 2 buckets or, a whole warehouse full of buckets, or maybe at home, like you buy, your toilet paper in bulk, you're buying the toilet paper before you need it in quantities that are larger than you need at that moment, okay? This is overproduction waste, and it causes all the other waste. Now, again, I'm not telling you that overproduction is waste, so you shouldn't do it. All right, so like some of you will buy your toilet paper, or whatever supplies or whatever at Costco or Sam's Club or whatever it is, or just Walmart, and you buy the big pack or whatever. I'm not saying to you that if you want to be lean, you're just gonna mail order 1 square of toilet paper at a time just on demand as you need it, okay? Because that's just silly. You're not gonna do that, okay? All I'm saying, I'm not telling you not to do this. I don't know if this is making sense. I'm not telling you not to do this. I'm just telling you just be able to look at it and say, aha, that is waste. That is not creating value. Nothing is changing. No inputs are being transformed into an output by buying things before I need them in quantities that I actually need them in. The only transformation happens when I actually need that item and I have it on hand. That's when the transformation happens. But everything that leads up to it is not value added. I'm just going to identify it as non-value added, label it as that, and then that way I can find creative ways of reducing it. All right? So this is the first one. Now, when you do overproduction, all the other wastes end up happening. So when I do overproduction, the next waste that happens is that you have inventory. So now you have stuff, and you have to keep that stuff someplace. Now, in your home, for most of you, I mean, unless you're just like a really crazy hoarder, the space probably isn't that big an issue. Like you buy the big pack of toilet paper, and most of it fits in the cabinet, the rest of it kind of slides underneath the bed. Or you buy the 24 pack of cans of whatever it is that you usually eat. That's the overproduction. And it's like you have room for most of it on the shelf in the pantry. The rest of it you like throw on the floor or whatever it happens to be, okay? So it's not that big a deal at home, but I'm saying in a business, when you have thousands and thousands of different parts and you're overproducing on all of it, buying or making it ahead of time, then you end up with needing all of this space to keep it. Now you need to build the warehouses. Now you need to have the racking systems. Now you need to have all of the additional expenses that go into those systems, like expenses. And waste equates to money, okay? So think about overproduction. You have capital money invested in the materials and the labor for those items before you actually need it. So this is a cash flow issue. Then you have to keep it someplace. Here are all, I mean, this is even all, but this is just some of the expenses that we have to have in our organizations because we decided to do the waste in the first place. And I'm not saying that if you were lean, you wouldn't have a warehouse or you wouldn't have forklifts. I'm just saying that we have this stuff because we had overproduction to begin with. And there's costs associated with it, right? I mean, inventory containers and shelving and employees and managers and electricity and water, forklifts, conveyors. I love this one. Computerized inventory management. We got so much stuff that we have to have computer systems to be able to manage where that stuff is, how much of it we have, what the storage locations are, how much money is tied up in that stuff, how to find it. Then if we're going to have computerized systems, we need to have the computers, we need to have the wiring, we need to have IT professionals. Then we have to have a manager to supervise the IT professionals. I mean, you can see there's a lot of money that's tied up in these sorts of activities that don't create any value for our customers, but it's stuff that we have to do because we decided to overproduce in the first place. When you experience inventory, you experience then waiting. So anytime you have those items in place, they're just sitting there. Those are inputs that are just sitting there and nothing is happening to them. It's waiting. It's an input just sitting there. So like when the screws are sitting here on the table, this is waste. They're just sitting there. Nothing's happening to them. The only thing value added is when they're actually being transformed. So you have this stuff sitting around. I mean, you've got like, you know, all kinds of inventory scattered everywhere, and nothing's happening to it. It's just sitting. You know, you can look at dates on boxes. You can look at dust levels on the tops of boxes to see how long things have been sitting there. And the more it's been waiting, the more waste that you know you have in that system. Now, when things are waiting and when they're sitting there in inventory, then you have to have transportation to go find them and get them. So imagine if you've done a lot of overproduction, and so you have all this inventory and you're keeping it in a big warehouse. Now you have all the transportation to take it down to where it needs to be stored, to put it up on a shelf. Now when you need it again, you have to go to the shelf, you have to pull it off the shelf, you have to look in the box, you have to get it out, then you have to put it back up on the shelf. So this is all transportation, moving things around. And then there's all of the cost that's associated with that transportation. Material handling devices, conveyor belts, forklifts, forklift operators, maintenance workers to run the material handling equipment, all the time and the resources just moving the equipment. And you saw this, you saw me, when I went over here and got the screws, did taking the screws from the rack over to my workstation, did that get the screws into the blocks? No, just transport, move them from there to there. Okay, it's just moving them around. So when you're moving things, that motion, that transportation is not value added. You also end up with motion, so motion waste. So motion and transportation are related. Transportation is where you take items and you physically are moving an item from one place to another. An input needs to move to some other location. Motion is where the employees in the operation are making motions, but the motions are not doing anything to create value in that system. So I try to give you a couple of examples. I'll throw this up here. I'll try to give you a couple of examples. In the morning, let's say that you want to make an omelet. And so to make an omelet, you're going to need a spatula to make the omelet, right? So where do you keep the spatula in your kitchen?
In a drawer.
In a drawer, okay? Does anyone have a name for the drawer? You don't, you just say the drawer?
Utensils drawer?
I call it a utensils drawer. Some people would call it a junk drawer. But you've got all of your utensils are in this drawer. Do you know what I'm talking about? That drawer in your kitchen?
Yeah.
Am I making sense to you? Okay. So you're getting ready to make an omelet and you need a spatula. So you open up the drawer and all you see are handles. And so you start shifting through those things to find the handle of the spatula. So this, what I'm doing right here, this is waste of motion. Okay. Finally, I find what I think is a spatula, but it's actually the whisk. So I put that back and then I keep looking and then I find a spatula. Except that this is not the spatula that I like using for omelets. I hate this spatula. So I put that back and then this is waste of motion. And then I find the spatula. Have I done anything to cook the omelet? No value added has happened, but I've done a lot of motion around, okay? Another example is motion is created by these computerized inventory management systems. Anyone ever use these? So if you worked in retail, you'll know you've used one. If you worked in retail where you had a computer system where a customer needed a particular size or color or whatever it happens to be, and they came up to you and they said, hey, I can't find this on the shelves, but I'd really like this in this color or this whatever. And so you say, okay, no problem, and you type it into your computer, and boom, it tells you that item is, on aisle B, shelf number 2 in spot 37, or whatever that happens to be. Anyone ever used one of these systems? Oh, awesome, a bunch of you. Okay, and then you confirm with me, okay? The cool thing about these systems is they are designed to keep track of our inventory in such a way that minimizes motion, because whenever you look up an item in that system, in that computerized system that we spent so much money on the computers and the IT and the technology to make that work, when we look it up and it tells us to go to that particular aisle and shelf location, and it says there's 3 of them in this location, you walk straight there, you look right there on the shelf, and there they are, the 3 of them stacked right up there, just pretty as can be, just like the system said. Isn't that the way those systems work? Because you spend a lot of money. Huh?
Never there.
Oh, what? Wait, isn't that the way they're supposed to work? It doesn't work that way? What happens? People move stuff. It's not there. The inventory in the computer system isn't correct. Okay, so then you end up going and you pull down the box, waste of motion, you're looking through the box, it's not there. And you're like, well, I think I saw these the other day over here, and you walk someplace else, and you're looking through there, and you don't find them. And you walk someplace else, and you can't find them, right? And then you go back to your customer, well, I guess we don't, guess we don't have any. Or you look in the system, and it says 0, and you say to your customer, wow, the system says we're all out. We'll put it on back order. Maybe we can get those in another week or so. And then on your lunch break, you're like sitting down at lunch, eating your sandwich, and you look to your right, and there's like a whole box of 100 of them sitting right there, and you're like, what in the world? This wasn't in the system, okay? So this is waste of motion, okay, when you have these problems in your system. And now I'm having the waste of motion because I lost my little clicker.
It's on top of the box.
Oh, look, yeah. Because I didn't have visual management. They're both black, gray, and I can't see them. How about that? So that was, see that? Waste of motion in my process, which created a delay, which created waiting, and you're all sitting, and nothing value added was happening during that moment. Does that make sense? It happens in all of our processes all the time. Okay, when you have these things, these also create defects. And we have defects for a lot of different reasons. You have items that that become obsolete, items that spoil, items that become damaged. Whenever you have transportation and motion in an organization and this inventory, it's an opportunity for it to be damaged. It'll fall off of a shelf. This happened to you before. You got something in the fridge, you pull out the milk, and it knocks over like the jar of whatever that smashes on the floor. Or you accidentally bump into something and it cracks the thing. Or, the chips, you have the stack of cans and you grab one can and the cans topple over onto the chips and then the chips are all crushed. Okay? So this happens in manufacturing as well. Things if they're on the shelf, they can fall off, they can get damaged, they can get old, they can become obsolete. All of these things can happen to them. They can spoil. So we've got all of these things and all the costs to identify and remove. But now we need inspections because we have defects, right? Right? Don't you have this? Like in your fridge, you did overproduction, which resulted in inventory that you kept in your refrigerated warehouse, and now it's spoiled, and now you have the waste of just motion just to throw the stuff out, okay? Plus, it's just kind of gross, okay? Overprocessing is when we've done something that is value added, and then because we had waste in our process, we have to do the value added stuff again. So we had stuff that was in a box, but someone bumped into the box or the box fell, now the box is crushed. Now we have to take the items out of the box and we have to put them into a fresh new box. Well, I'd put them into a box already and now I'm putting them into another one. Or in my process here with the screw, right? I screwed it in, which was value added, but I went too far, so I had to unscrew it and screw it in a little bit again. The unscrewing and screwing it again, I'd done it once already and now I'm having to do it again. This is over processing. This is when we've done something once and now we have to do it again. And these are the wastes, these are the 7 wastes of lean. And I want to remind you, I'm not telling you this because you blindly go into a process and just get rid of all of it. You have to do it very strategically, and you have to think, what is my process, what value am I trying to create, and then we're going to use our creativity to get rid of that item. Let me give you one more example of how this works, especially since I've got this slide up here. And so you might be recognizing at this one, because I want you to be able to see waste in your own processes. And there may be some of you that are saying, well, I just think that that's stupid. Because what I do is on Sunday, what I do is I cook a big meal, and I take that, I cook the big meal, spend all the time to do the value added to cook the big meal on Sunday, and then I put it up into small meal-sized portions, and then I can use that during the week, and that saves me time. And you're saying to me that that is waste because it's overproduction that causes inventory and all that other stuff. I am not telling you that if you want to be lean, you shouldn't cook your meals ahead of time and use them through the week. Okay, that's not what I'm saying. I'm not saying if you want to be lean, you're not going to pre-bake your meals. But I want you to recognize that when you pre-cook your meals and use them throughout the week, there's waste involved in that, and that overall, in your overall time, you probably aren't saving much time at all. But instead, what is going on is you're saving yourself time in periods of time where you need the time, where the time is more valuable to you. So let me walk through this process so that you can see the waste in this process. You cook the meal, and there's going to be non-value added in there, which is pulling the food items out and setting them on the counter and moving them around the kitchen and finding the spatula and the cooking supplies and all that stuff, and the big containers and doing that. But then you do the cooking, which is value added, okay? So that's like me screwing in the screws. You do the cooking, you cook the food, you blend it, you heat it up, you do all that. That's value added. Okay, so now it's value added, okay? So then you're going to take part of it, you put it out on a plate and you'll eat it, great. But then you take the others. Now what you have to do is you have to get little containers. This is non-value added. You have to open up your cabinet. You have to find little containers. You have to find the containers where the lids match the bottoms or whatever that is. You have to lay them out. Then you have to take your food items and spoon it in. All this transportation motion to store the inventory. Then you put all the lids on. Then you carry them over transportation again into the refrigerator or wherever that they go, into there. Okay, so now it's inventory that's in there. And then you go, and then when you need it, you go and you grab that item out. Okay, so again, transportation motion. Then you have to take the lid off, and then you have to transfer it onto a plate, often that's microwave friendly. Then you have to take it over to the microwave. Then you have to heat it up. Now you already heated it up once when you cooked it. Now you're heating it up again. That's this over processing. You're doing the heating twice, okay? Then you pull it out, and then you have to eat it. But then you have to wash the container that you had. And then you have to, after you wash it, you take it out of the dishwasher, and then you have to put it away. So there's all this activity that you wouldn't have to do if you didn't do the over-processing at the beginning, okay? But the time, it saves you the time in the cooking in the moment. But the thing is, if you could find a way to efficiently do your cooking in the moment, you wouldn't need to do the over-processing at the beginning, which would save you all of this inventory. Plus, this has probably happened to you before. You forget about a container that gets stuck in the back of the fridge, and then 3 weeks later you end up with, the picture of the strawberries with the fuzz on them, okay? All right, so, and again, I'm not telling you not to do it. I just want you to be able to see that there is waste and then think creatively, wonder how I could reduce that waste, okay? Maybe there's a way to do it, maybe there's not, but you use your creativity. So let's try to do an overview of these 7 wastes. In order to be able to see waste in your process, you have to understand the definitions of the different types of waste so that you can recognize them in your processes. And of course, you're also going to want the people that are working for you to be able to see these types of waste. Some companies have said, we'll just have our people memorize the waste, for instance, using the acronym. But companies today, what they're doing is they're saying, what people need to understand how these wastes are connected, how they're connected in terms of real processes. So a lot of times they'll have their people explain the wastes in terms of a story. And so when you see a production process, you can usually find the 7 types of waste. And there's lots of YouTube videos where people are describing the 7 wastes in terms of different processes. But one thing that I'll encourage you to do is the next time that you are doing a production or a purchasing process, you're buying something at the grocery store, or you're producing something, for instance, when you're making a meal in your kitchen, I want you to look for the 7 types of waste and look for how you are creating these wastes in your process just by the way that you have configured those processes. So, for instance, you might say, well, I'm going to, make a meal, but I made too much for the meal, and so that's overproduction. That overproduction is making more than I need before I actually need it. Because I made more than I need before I need it, I have to store it someplace. I have to keep it someplace. So I put it in the refrigerator. I have to put it in a container and put it in the refrigerator where it sits and it's waiting, and nothing's happening to it, and nothing's being transformed. Sitting there in the refrigerator as inventory. And then I have to get it out of the refrigerator then to use it later as a leftover. So that is transportation. I have to open up lids to containers. A lot of times I'll have multiple containers in the fridge and I don't know what's in each one, and so I have to lift up the little lids to see what's in each one, and that's motion. Sometimes I find something in the back of the refrigerator and it has gone bad, and that's the defects that are there, and then I have to either warm it up again, or I have to scrape off the bad stuff off of it, or whatever that happens to be, which is the over processing, transforming items multiple times when I should have just done it once. There is the 8th waste, which is mentioned here in this slide, and so I wanted to describe that to you. And it is commonly used. I would say it's very popularly used in businesses where they say the 8th waste is the waste of untapped human potential, or it's the waste of not utilizing human intellect. And the principle there is when we have professionals, or we have people in our organization that are highly trained in lean, that we be responsible for deploying all of the improvements, then we aren't tapping into the power of the minds of every person in the business. And what we would rather do is we would rather have every person in our business be able to see waste in the business and really be able to understand what is waste and what's not, to be able to help us creatively improve processes. And so the most advanced companies that are practicing lean really do get everyone in the business involved in improving processes and seeing where waste is and seeing how we can improve those by removing the waste, by finding ways to get rid of the waste. Now, one question that I will get sometimes from students is they'll say, well, so show me, I'd love to see a video of a real process that really does have very little waste in it. So, I mentioned earlier in this video that a world-class business process that would just be absolutely amazing might be 80% waste. So can you show us a video that kind of looks like that so we can see what that looks like? So I have another fun one that I want to show you, so this process is a process that would be considered, I haven't actually measured, but I would suspect it'd be something like 60% waste. So I mean, this would be like way beyond world class. This would just be absolutely amazing if you were to ever see it in real life. And notice that I did say 60%. It's still mostly waste, but I want you to see what a process that has very little waste actually looks like, and then we'll chat about it for a minute.
The Visa check card. Because money shouldn't slow you down. Life takes faster money. Life takes Visa.
So now you tell me, real process or fake process? Fake process. Okay, so obviously not a real process. But remember, I told you at the beginning, I said one way to think about a mindset in lean is that in lean, we kind of, in our minds, we have this vision of the ideal way or the ideal state. And how much waste is in the ideal way? Zero. Okay? The ideal way would be zero waste. So even this process is way, 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 way far away from the ideal state. But if you want, you can kind of think of this process, you can kind of think of this as being like a waypoint between wherever your process is now and the ideal state. You can kind of envision, what if I could get my process to be like that, okay? So now there actually is, even though this is a fake process, there's actually a lot of features about this process that we incorporate into real lean systems. So let me talk you through some of those things. A couple of things that I like in here. One is that they're serving customers one at a time. It's what's called one-piece flow. I have a playlist on YouTube entitled One-Piece Flow, where you can see people in real processes doing side-by-side comparisons of what it looks like to work in what we call batch versus one-piece flow. We'll talk more about that next class session, and then we'll continue talking about that for several classes after it. But they do this one-piece flow in here, and what I mean by that is, like when they're doing the shakes, they make these shakes, and it's like they make green shake, blue shake, orange shake, the different color shakes, and then they toss them down the table, and they're making it in exactly the order that the customers need them, right? The customers come through, and somehow they know what shape each customer wants, what color it is, and they make it on demand as it's needed, in the order that it's needed, right as it's needed, so there's very little waste in there. So that's one convention that they use here in the video. Probably one of the biggest ones here in the video is that I mentioned to you before, in lean processes, we will configure the processes so that waste and problems become visible. So that when there's a problem, we know about it right away, okay? And this happens in the video, right? Everyone's paying with the Visa check card and everything's running smoothly, and then all of a sudden there's this thing that happens. I don't know, what exactly is going on. This guy, he doesn't realize that this is like the Visa check card place, and he pulls out his wallet to use cash, and then this creates all kinds of problems. And what happens when he pulls out the cash? What happens in the process?
Slow down the process.
Yeah, the whole process, like, it stops. Like, I mean, we're talking people crash into each other, stuff falls on the floor, there's like, trays and everything are falling over the floor, making a bigger racket. Does that make sense? But the whole process, for everyone in the business, the entire business, everything stops, okay? And we'll actually design, I'll show you how we do this in real lean processes, but this is what happens in real lean processes. We design it so when there's a problem, everything stops. Now here's the other thing that goes on. Everyone that's in that system, okay, so when you look at everyone in that room, I mean, the music in the commercial stops, okay? But then what does everyone in that room, what does everyone do when the process stops?
They all look at the problem.
They all look at the guy. Does that make sense? Because when that problem happens, it is so obvious where the problem happens. They focus, their attention immediately goes to right exactly where the problem is, because we have made it so obvious. When there's a problem, it's going to be obvious where that problem occurs, and everything in our system will focus on that one problem area whenever that problem happens at the moment that it happens. Now, I will tell you in the video, the people in the system, they do not have a lean mindset because they don't just look at the guy. They like give the guy the death stare, right? They're like glaring at him. That's very much the a mass production mindset. They're kind of looking at him like, what's your problem? Why are you stopping our process? Does that make sense? That's what we call shame and blame sort of mentality that exists in most mass production mindset organizations. That is not what would happen in a lean organization. So if this were a lean video, what would happen is the guy would pull out cash, everything would stop, trays would fall on the floor, everyone would know what would happen, everyone's eyes would go immediately to this guy, but then everyone would gather in and everyone would say, okay, what happened? What's different in the process now? Why did this, occur? Well, I tried to pay with cash. Okay, well, we would try to do root cause problem solving. I don't know what the answer would be. It might be that this guy just didn't know that the Visa check card was even available, okay? And had he known that the Visa check card would make his process easier, he would be more willing to use that. So maybe that's what it is. Maybe it's just that he didn't know, and maybe we have some system in place so that when new people come into our system, they know what is going to be easiest for them. But it may be that the customer's needs have changed. So maybe we had this system where people use the Visa check card, and so we designed the system around that Visa check card, and all of a sudden, the customer's mentality has changed, where the customer now wants the option of paying with cash, okay? And this is where, this is that organism viewpoint. Now the customer has changed. So now maybe we need to create a different system that either routes people where, if you're going to use Visa check card, you use this process, and if you use a different one, you use this other process. Or maybe we need to create flexibility into our system to be able to accommodate both Visa check card and cash. And that's going to take some process redesign, figuring out how that's going to work. But we don't blame the person. What we do is we say, how can we change the process to make this better? All right. The last thing that we can kind of see in this video is this is one of the counterintuitive facts about lean. I think this is interesting to me. Let's say that you are a member of a student organization and you need to put together packets for something. I don't know, there's some sort of a training maybe that your organization is putting on, and you need to put together a packet. So, with a packet, what that would be is where you have different pieces of paper, and you've made a bunch of copies of a bunch of different things, and there's different materials, and they all need to be like collated in together. In a certain order, and then some things need to be stapled and other things need to be clipped, and they all need to be put into a binder. Does this make sense, like what that process might look like? Is that okay? Is it some nods to help me? Am I connecting with you or not? Do I need to pick something else? Is that okay? Okay, so let's say that's what you're doing. Let's say that you're supervising this process, and you have a team of 5 volunteers, and so you show them how this process works. You get them into a room, you say, hey, here's all the materials you need. I want you to put these things together. Here's the order. You staple these, you clip these, you put these into a binder, you know, and this is where they need to go. Put them into that box afterwards or whatever that happens to be, okay? You give them all those instructions, and then you say, hey, I gotta go run an errand, and then I'll come back later, okay, to see how you're doing. Everybody all right with me so far? Okay. Now when you come back and you open the door to the room and you look inside, what you want, and you can think to yourself, when you're in your first job, when you are supervising a team of people, these may be people that, you know, you are responsible for, that are being paid by the organization. You want to know that they have been productive while you were gone, and you want to know that they are currently being productive now. Isn't that right? Like if we're paying these people to work, don't we want them to be productive and work? Does that make sense? Okay, so you're coming back after being away for a while. You want to know that while you were gone, they were productive, and that when you open that door, you want to know that they are currently being productive. What sorts of things in the room, what sorts of things either happening or what sorts of physical things in the room would you be looking for to let you know that they were productive and that they are being productive? What would you look for?
Outputs.
You would look for outputs. You would look for, like, what would the outputs in this case be? Stacks of these packets, right? You look for these big stacks of packets that are all completed. That's what you look for. And then what would you look for the people doing? What action would you look for? What's that? Making more, which would look like what? What would it look like? Would it look like this? Is that what it would look like? What would it look like?
Busy working,
What would they do? Busy working by doing what?
packing.
What would the busiest people look like? Huh? Yeah, the busiest people, right? They'd be grabbing stuff and put it in it and grab it over here. I've been working hard the whole time. I need more of these papers. Let me grab them from here. I am the most productive person in the room. Isn't that what you would look for? Like, that's the most productive person? Isn't that what you would, but isn't that what, I mean, that's what most people would look for, right? What's so funny is that everything that you look for to try to determine if people are being productive is all waste. You're looking for the inventory, you're looking for the motion, you're looking for the transportation. When you walk into a factory and you're trying to see if it's productive, you want to see conveyors rolling, you want to see forklifts rolling from place to place, you want to see inventory stacking up, you want to see people walking back and forth. But everything that you look for productivity is waste. In a lean process, the most productive processes would look like no work was happening at all. And that's kind of a counterintuitive thing. Kind of like in the video, you see the people, I don't know if you remember, there were some guys, there's like a grill or something, and the guys have these spatulas and they're doing this. Like that's the only motion that they're doing, and like whatever they're making is flying off the grill, different locations, but all the action they're doing is this. And then when the inventory goes off, it goes into people's hands right away. Right? So there's very low inventory because the inventory gets used right away. And there's very little motion because there's still motion, transportation in the video. That's why I say there's 60% waste. But it's just that truly productive work looks like almost no work happening at all because you don't see any motion, transportation. It all happens in a very, very small space because you've removed a lot of that stuff. Here's the principle, river in the rocks. This is one way that we improve processes in lean. We think of this is another metaphor, okay? We've got a river here that has flow. The river runs through. As long as we've got flow, we're producing value for the customers. The water in the river represents inventory, and you have to have inventory to have flow. So if I tell you your inventory in your kitchen is all waste, get rid of all the food out of your kitchen and pantry, and then I go to ask you to make me breakfast, you gonna be able to make me breakfast? No, because you have to have inventory to have flow. Inventory is a waste, but you have to have it to get flow. What we would like is less inventory. So what we do in lean is very strategically, we slowly reduce the amount of inventory, and reducing that inventory gets to the point where it highlights a problem, it exposes a problem. These are rocks in the bottom of the river that we can't see because we have inventory. And so when we get down to this level, it exposes a problem. That tells us this is a problem that I need to solve. Oftentimes then we'll increase the amount of inventory so we have flow, so we can meet our customer need. Then we will focus on this problem because we know it's there. And when we solve this problem, it's like taking that rock and throwing it out of the river so we don't have to deal with it. Then we reduce our inventory again till we hit our next problem. In Lean, we have another saying that's called no problems is a problem. We want to see the problems because we know the river is full of problems. The only way we'll see them is by lowering the amount of inventory. We actually do it strategically so that the problems happen, so that we can find them, so that we can fix them. So here is the beginning point. So the very first thing is to pick a process to improve. And this is really important, especially if your company has never pursued Lean before. It's important for you to pick a good process to start with. So what makes a good process to begin with for improvement? Because when you embark on Lean, when you begin making improvements, you want to make an impact on people's lives. You want to make sure that you're going to be successful in your first attempts at this, because if you start telling people, hey, we're going to improve, and then you can't improve, then it makes it harder to keep that effort going. So how do you know what would be a good process? The only thing you need to be able to do is be able to see that there's waste. If you can see those wastes in a process, you see a process, the more of those wastes that you can see, the better the candidate, the better the job is, the better the process is to be able to try to improve it. I'm going to show you video of several processes today where we will identify waste, and you're going to see the waste that's in these processes. So if you see processes that are similar to these, and encounter them, then they would be great processes for you to be able to begin improving. When you begin improving processes, you do not need to know how to improve the process in order to begin improving the process. So maybe this is kind of a counterintuitive thing. Some processes you'll see, and you might say to yourself, you see this process and you say, oh, that process is really messed up, and I know what I'm going to do. I know what I'm going to do to fix it. Okay? Now, if that's your attitude going in, if you say, there's a messed up process and I know what I'm going to do, then you will not be able to achieve the big improvements that I'm going to be teaching you in this class. Because what's going to happen is you already know how you want to improve that process, and so any of the creativity that's involved in problem solving and in improving these processes, you're going to block that out of your mind because you already know where you're going to head with this, all right? So it's actually easier to improve a process if you don't know how to improve it from the beginning. And I know that sounds weird. Now I'll tell you, I have years of experience in improving processes, so this is actually a really hard part of the process for me. I have to make a conscious effort, because a lot of times when I see processes for the first time, they have similarities to other processes that I've dealt with, and in my mind I say to myself, oh, I know where we're going with this one. I know what we're going to do. And I have to purposely block that out of my mind, because the fact is, at that point when I've just first seen the process, I haven't been to the Gemba, I haven't gotten my hands dirty, Genchi Genbutsu, in the middle of that process to experience what's going on. So, and I haven't even evaluated what's waste and what's not waste in there. I don't know what the customer wants, I don't know what creates value, and here I'm trying to solve a problem. I don't even know what the real problem is. So I have to really work on blocking that out of my mind and just look for the waste. If I can see a process with waste, then that's all you need to be able to begin. So we'll find a process with waste. Next thing is to get support from management and the process workers. This is important as well. And I'm going to just invite you to recall back to the little cell phone exercise we did in class where we traded cell phones and changed the settings on our cell phones. Remember, if you don't get the process workers buy-in, then they will, they're going to block you the whole time. They will keep the improvements from happening, because remember, this is their process, not your process. It's their process that we're changing. The key here is not to get the process workers to adopt your ideas. The key to this is to open the eyes of the process workers so that they can see the waste in their own processes, because if you can teach them to be able to see the waste, they will begin to look for ways to improve their own processes, and may even invite you in to help them figure out ways to improve the process. Same thing with upper management. This is one reason why a lot of Lean initiatives fail, is because top management doesn't support Lean. So if top management is not, the top management in the company, if they're not supportive of lean efforts, if they don't understand the benefits of lean, then this is not going to be successful. The best way to improve in those cases, because I'll get these questions from students sometimes, well, no one else in my company does lean. How can I get my company to do lean because I see so much benefit? Your only way around that is just to practice yourself. Just to practice yourself, because when you do, you'll demonstrate excellence in your own work, and people will begin to wonder how and why is that happening. Okay, and so that's kind of how you go about it. But you need to get management's approval or management's support of this. Two kind of ways. The best scenario is when management is in full support. Management fully believes in lean. They're practicing lean, and they want it to happen in the organization. That's best case. Sometimes you can't get that. So the next best thing is just to have management being open to trying some new things. And the way that would look is you go to your manager and you'd say, hey, I think we can improve a process over here, using some techniques from lean. Are you open to me, to us, trying to restructure how this process looks? It won't cost any money. It'll just take us some time putting things together a little differently. And would you mind us just experimenting? If it's better, we can keep it in place. And if it's worse, then we'll put it back the way it was. But can we experiment? Because that's really all lean is. Lean is just a big experiment. It's a series of little experiments as you go along. So that might be a way to get in and be able to improve a process. I will tell you that that works for business processes. It also works for personal processes. So we're going to talk a little bit during the class about all of our kitchens, because that is a gemba that we all have in common, is our kitchens. Okay, so it gives us a good opportunity to talk back and forth about that. You may decide that there are some things in your kitchen that you would like to restructure because you would like your cooking processes to take less time. Okay, now I don't know who you are, what you do in your kitchen. For me, in my kitchen, in our family, we aren't real big fans of cooking. Some people are. Like, it looks so romantic. You see some of these television programs, and you see the couples, and they're in the kitchen, and they love each other, and they're cooking, and they're just having the best time in that kitchen cooking. Okay, I don't understand that, because I don't enjoy cooking. I like the eating, okay? I like the eating a lot. I just don't care for the cooking part. I would rather, if I could make the cooking piece faster so I don't have to do so much of that, so that I can do more of the eating. But now I don't want to hurt the quality. I want the quality to be better too. Okay, does that make sense? That's what I want. I will also tell you, I'm just going to go ahead and I don't know if any of you are chef people. I've had a few students in my classes in the past. I remember this one person specifically, and they said to me, yeah, like, I am a part-time professional chef. Like, I have a side job as a chef. If the whole supply chain management thing doesn't work out, I'm gonna become a Michelin-rated chef and like work in this restaurant. And I love being in the kitchen. Like, it's my quiet place. I go to my kitchen, and that's what I love doing. And so I had to let this person know right away, like, do not practice lean in your kitchen at all, because you're gonna hate it. Because it's gonna make the cooking so much faster, and it's just gonna destroy all your joy. Because I know you just enjoy being in there and doing all your stuff in that kitchen. So if that's you, don't practice lean in your kitchen, because you're going to make it 50% faster. But if you're like me, and you want to make it faster, you might want to practice it in your kitchen. That was a way long introduction for. When I began practicing this, I recognized that there was a lot of waste in my cooking processes, and I wanted to begin doing this in the kitchen, but I'm not the only one that uses the kitchen. Okay? So we had to get everyone in the family on board. At the time, now since then, my wife has adopted a lot of lean practices, honestly, and embraces a lot of it because she sees a lot of the benefit in it. But at the time, she was just scared about it. Like, I don't understand what you're gonna do. It sounds like you're gonna ruin the kitchen. I don't know that we want to do this, okay? And so this was the tactic that I used, which was, I don't wanna mess up the kitchen. Can we do this? Can we try some new things out? And we'll try it out, give it a good effort for a couple of weeks. And then if you don't like it, or if it doesn't make things better, then we'll just put everything back the way it was. It's not like we do a big remodel that costs us any money. It's free. We're just doing things a little differently. And so that was a lot more accessible. And so she was like, yeah, sure, we'll do that. And so we did it. We just practiced, put things in place in a little different way and try it out. I gotta let you know, and we'll see more about my kitchen as we move through the semester, but to this day, this was several years ago, and to this day, my wife and kid will just be in the kitchen and they'll just exclaim, in the middle of cooking, they'll just exclaim, I can't believe that we ever cooked the way we used to cook. Things are so much better now, the way that they are now, than the way that they used to be. Like, it was so ridiculous. I can't believe we did things the way that we did. Because it actually did. It made things better. So that's one thing you can do. Then spend lots of time in the Gemba. You want to be in there experiencing that process, experiencing the problems, understanding where the problems are, where the waste is, documenting that, writing that down. Then take a lot of detailed pictures and video of everything. So go through with your camera. You're going to take pictures of, literally everything. Take pictures of the inventory. Take pictures of the shelving, the racking. Do video. Video the process happening. Video the tour of the work area. This is the work area. This is what it looks like. This is how it's used, and then a video of the process actually happening. In a few minutes, I'll show you. We're going to be doing some really high-level time study analysis sorts of things, and video comes in handy for that because you've got the little time counter that's down in the corner, so you can measure time elements. But the bigger piece is that we can show before and after pictures. We can show what the process was like before and what it is like now. We can do video of the way the process was before and video of the way the process is after. And that helps with the culture building in an organization because you can share that with the rest of the organization to say, this is how we've made improvements and this is how much better things are. Then you're gonna answer the following questions. Okay, so this is the key to doing what we're calling a value-added, non-value-added analysis, which is where you're going to determine what is value added in this process and what is waste. Now, I identified last class the 7 classic wastes, and we should be able to identify those in our processes, but we need to be able to determine what is value added, what is waste. And the way that you do that is you answer these questions. Now, again, if you don't remember, it's okay, because we're going to review it here. Does anyone happen to remember the definition of waste that I gave earlier, or something close to it? Do you remember what it was kind of about?
Not added value to the final product.
Not adding value, right? And so we call waste non-value added, so that's perfect, okay? Remember, what was the definition of a process? A process is inputs that are transformed into an output, okay? Inputs being transformed into an output is a process. Anything what we call value added is when the inputs are being transformed. So anything that is doing a transformation of the inputs into an output, value added, everything else non-value added, okay? So we've got to answer these questions to determine that. We want to know who's the customer, what do they want? Because that's going to tell us what defines value for this process. What is valuable to that customer? Then we say, what's the purpose of the output of the process? What are the outputs? And we also need to determine what are the inputs and what transformation is happening. So we're actually defining what are the inputs, what is the transformation, what is the outputs, and what should those outputs be like in order to create value for the customer. We have to answer these questions to be able to determine what is value added. Anything that is an input being transformed into an output is value added, everything else non-value added. Then what you do is watch the process and determine what is value added, what is not. You're going to measure the small bits of how much of it is value added. That's the easiest thing to do is just look for the value added pieces, measure up the total time for those. Everything else is non-value added. And the reason that we do this is it's just like other things that you've done in supply chain where when we're making an improvement, we're going to measure a current state and then we're going to make an improvement and then you're going to have the improved state so that you can document how much the process improved, and that's all we're doing here. So we're going to measure value added. We're going to measure the distance walked. You've done this before. Like I was just at the SPO orientation last night, so I was around Dr. Wayhan. So I must have like Wayhan on the brain. But when you took Dr. Wayhan's like one of his his sourcing class or strategic sourcing, right? You get data on all of the company's expenses, like what are they spending on this category of materials, and then you figure out ways of rationalizing those expenses or rationalizing those suppliers, and then you come up with a new way of structuring their purchasing so that it's lower, and you know how much they spent on materials before, and you know how much they're spending after, so you're able to document how much it improved. Does that make sense? I mean, so you've done it in other classes. That's all we're doing here. We're just saying this is how much value added This is the value added piece of it before, going to be value added piece after. How much are we improving in that process? So we're going to summarize these: total time for the whole process, percent value added, and typically total walking distance as well. And I'll just give you kind of a preview. Typically when we do a process improvement, we're going to drastically reduce the amount of time it takes to do a process, but the value added piece will probably not change that much. So remember, I had like a column at the beginning a few sessions ago that was like total time for the process, and the value added piece was just this little sliver at the top. And remember, in Lean, we're going to be focused on the non-value added, reducing that. We aren't trying to speed up the value added part. So usually the total value added time after will probably be about the same as it was at the beginning. Many times it might actually, the value added piece might actually be a little longer, because remember, what we would like is we would like for people to work slower. We want people to do the value added pieces slower so that we impart better quality into that process. We're just removing the non-value added. So the percent value added might be, it might be 1% value added at the beginning, and it might be 2% value added at the end, and that's a big improvement to going from 1% to 2%, but the total time for the value added piece would stay about the same from the beginning to the end. It's just that the total time for the process will be reduced. All right, what's next? Okay, good. So now, great. So now we get to practice looking at processes. So here's what we're going to do. We're going to look at a variety of processes. And just to remind you, I haven't really taught you anything about how to improve a process yet. All I want to do first is teach you how to be able to recognize value and recognize waste in a process so you can see those things. I will tell you, though, that during today's class, I will ask you some pointed questions about parts of these processes, and we'll try to brainstorm some ways to improve. But these are like the easy wins, okay, the stuff we brainstorm in here. I'm going to show you some really cool tools over the next several classes to really improve processes really drastically. But we may end up getting some really big wins just today, just being able to see the waste. So let's see what these look like. All right, so this is the first process that we are going to evaluate. So I'll explain what it is, but what we're going to end up doing is we're going to watch videos of some processes, and we're going to, in each one, we are going to go through the same process that we've been talking about here, where we're going to take a look at who the customer is and what they want and what the value is that's being created, and then we're going to carefully watch the video to determine what is value added and what is not value added, because the important thing here is we'll have a total process time, and then what we want to do is we want, in a very detailed manner, we want to detail just the few activities that are considered to be value added, and then everything else will be non-value added. And for the non-value added, we can kind of summarize the non-value added in really large chunks and say, most of the non-value added time is taken up by whatever the activity is, and then that will help us to be able to improve the process. And again, I haven't given you really any tools other than just being able to see waste. I haven't given you any tools for improving processes yet, which we will get to, and some of them are really innovative. But for now, we can just look and see where the waste is, and I bet in these processes that we can find ways to improve them before we really even know a whole lot about Lean and about some really cool tools for improving them. So these all come from real student experiences where they have taken videos of real processes. These are real things that happen. Now let's talk about this first one. So this first video, what we're going to see, we won't watch the whole process because it's pretty long, but we're going to watch a good portion of it. And this guy that's in this video, what he does is he's got a shop where he installs car alarms. So a car comes in without an alarm, and they say, we want to get a car alarm, and then he is responsible for installing that car alarm into the car. So let's ask these questions just like answer these questions just like I mentioned before. So the first one is, who is the customer and what do they want? So the customer is a person that owns a car, and the thing that they want is they want a car alarm. They want a car alarm installed on their car that works. so that somebody's trying to break into their car, it makes a lot of noise. And they don't necessarily care how that happens, except that, they don't want their car damaged. They want their car to look the same as it looked before. It's just that they want the car alarm to be on there. So what is the purpose of the process? So the purpose of the process is to install an alarm onto the car. And we can talk about what are the inputs and what is the transformation and what is the output. So, the inputs here are the car and the car alarm. So we have the car and we have the alarm system, and the transformation that occurs is when those two things come together. Now, we will have to make some determination of how to define really what that transformation is in some of these processes, and I'll tell you that it's a little hard to do removed from a process by watching a video, and so we'll just make some judgment calls here, but the way that this happens really in real processes is by being in the Gemba, by going to the Gemba, speaking with the operator, being a part of what happens, which is what this student did here, be a part of what the process is, and really understand it at a deep level to really understand what that transformation is. So what we're going to do is we are going to define transformation for this process. The way I'll describe it is there are going to be certain things that need to be taken off of the car. Okay, so they are attached to the car currently, like the dashboard, and it is going to need to be taken off of the car. There are some things that will need to be disconnected, and then there will be some things that need to be reconnected, and of course the car alarm will need to be connected, and then we'll need to put the car back together, put the dash back together again. So anytime that we have some physical connection to the car that is physically disconnected, and then anytime that we have some physical connection of some item that is being physically connected to the car, those tasks will be considered value added. And we're going to define everything else in the process, regardless of what happens, everything else non-value added. Okay, so the things we're looking for here is we're looking for inputs transformed into outputs. We're looking for things dealing with the car alarm being attached to the car, and we're also defining here if there's something that is attached to the car that is taken off of the car, when that attachment is disconnected, then that is going to be considered to be value added as well. So what we're going to do is we're going to watch this operator. I'll be talking through it while you watch, and for this one I think I'm going to talk along with it, and then you can kind of see what happens here, and then when we get to the next video that we deal with, the next process we deal with, maybe I'll give you the opportunity to identify what is value added, what is not value added, and we'll talk through that, because it's going to be important that you're able to see the waste in the process. Okay, so let's go ahead and get started. So you can see here the operator is walking around, opening some things up, looks into the car, kind of sees, okay, what is it that I'm going to need here? What kind of screws are needed? Come over to the bench, grab a screwdriver and it doesn't have a right battery, or the battery's out, so we'll have to charge that up, get another drill out, get the charger out, put the battery in, find the plug that in. Okay, now we've got it. All right, so what you saw there was that the operator just went over to the car, said, well, what do I need? And then had to walk over to a workbench over at a different place, struggled around a little bit to figure out where things were located and where to plug things in, but eventually makes his way back over to the car. And so you could see in that whole process, the operator did a lot of activities, but has not yet done anything value added. So everything so far is non-value added. Next, what you're going to see is you're going to see the operator reach under the dash and is going to need to take some screws out of the dashboard so that he can pull the dashboard off, and then he's going to pop the dash off of the car. And so when his screwdriver is physically removing the screws, that will be value added. When that dashboard is popping off of the car, that is value added, but everything else is going to be non-value added. So I'm going to try to point out the value added happens pretty quickly, so I'll try to point this out as we go through it. So here the worker walks over to the car, reaches under it, value added, value added, value added, value added, and then reaches in, grabs, pop, pop, the little pop and the pop, those were value added. So you can see there, the operator walks over to the car, has to put the screwdriver in the screw. All of that is non-value added. The only value added piece was when the screw was actually backing out of the dash, and so there were a few screws there. The operator just drops them on the floorboard of the car, and then reaches under and has to pull that dash off, and only the parts where he's yanking and it actually pops off is considered to be value added, and everything else is non-value added. Okay, so next we're going to skip ahead a little bit in the video. Eventually the worker does get the dash off of the car, sort of sets it off to the side, and now the worker needs to take a look inside, see what sorts of tools and things that are needed, and then is going to go get the tools that are needed to be able to do the next part of the job. Alright, so the worker walks over to the table, grabs a couple of tools, is looking around for something else. There's something that's missing here. The worker goes over, looking under things, looking in a different toolbox, different drawers, comes back over, kind of scratching his head, looking around on that desk of a bunch of different stuff there, looking under boxes, back in another toolbox, and in the top it just says, alright, forget it, I'm just going to set these down in the car. So he kind of just sets them down in the car, and he says, okay, I'm going to come over here, let's do this part of the job. And he comes over here and he grabs these little plastic pieces out of here, and then he's going to walk back over to the car. So let me explain to you what he's getting ready to do here. So those little plastic pieces, those are used to connect wires together. So he's got some wires, and he needs to, a wire from one piece and a wire from another piece that perhaps there's a wire that's connected to the car and then another wire that's connected to the alarm system. He needs to connect those wires together. The way this works is there's those little plastic pieces. It's like a little plastic sleeve or plastic tube. It has some metal inside of it. He puts the wires together that need to be connected, and he slips that little sleeve over the wires, and then he's going to take a pair of pliers and he's going to squeeze the metal piece inside the plastic, and basically he's going to squash that tube on the wires, and that's what's going to hold the wires together and keep them from coming apart. So you can see he didn't count those little plastic pieces that he has there. He just grabbed a selection of them in his hand and dumped them there in the floor. You can kind of imagine that eventually he's going to have to figure out, he's going to have to sort of move those things around and feel around to find the right one that he needs. But what we're going to watch for here is he's going to take one wire and put it next to the other wire. Now, putting one wire next to another wire, that doesn't make a transformation. That's just motion. That's just moving a wire from one place to another. Okay, he's just going to move those wires next to each other. That's non-value added. Then what he's going to do is take that plastic piece, and that's going to be slipped over the wires. He's going to take his pliers and he's going to crimp down on it. He's going to squeeze the pliers to create that crimp to hold the wires together, and only the motion of the crimping is considered value added, because that's when the connection takes place. All right, so let's take a look at how this part of the job is done. All right, so the worker grabs it, crimps and crimps. Okay, so that is value added, then moves that stuff out of the way. So you can kind of see there, sort of pinch the wires together, and then just that crimping action was value added. So far in this process, we've watched it for a little bit, and so let's evaluate. So there's a total time, and we take the video and figure out how long that total time was. We're going to evaluate the value added that we've seen, and in this video so far, the only value added we saw was the screws backing out, little screw backing out of the dashboard, the popping off of the dashboard, and then the crimping of that one wire. So those are the only things that we've seen that are value added. I mean, out of all that video footage, I mean, maybe 5 seconds total of value added time. All the rest of it is non-value added. So what we would do is we would detail, put in detail, write down in detail what the value added steps were in the order that they needed to be done and the length of time for each of those value added steps. We would add all of those up. We would calculate a percent value added. Just take the total value added time divided by the total time. And then we would also highlight, well, where is most of the non-value added taking place? And so in this video, we can see that the non-value added, now there's a lot of non-value added activity in here, but primarily the biggest pieces of non-value added activity are walking around the shop, walking to different parts of the shop, looking around for tools. There were a lot of times that the worker picked up a tool, it wasn't the right tool, or went around and had to find it from someplace else and kept looking around, lifting things up and putting them down, you know, and walking back and forth from his various workbenches over to that car. There was also the issue of the of that electric screwdriver that he had, the battery not being charged. But the biggest pieces were walking around the shop and looking for tools. So, you know, now we haven't done, you know, anything really with this yet, but I'll bet you could probably think of ways to improve this process. You know, maybe even just us talking about it, you've already thought that of some ways that you could improve. And I'll tell you what this student did in this shop was talk with the shop owner, and they worked out a way. One of the biggest innovations that they created was they made a little rolling cart. They just got a little like a rolling cart with a flat top on it, and they put on the cart, they put just the tools and the supplies that were needed to change a to install a car alarm, and put those in the order that were needed on the little cart. Now, you know, we'll learn some other things. They use some labeling and color coding and some things like that to help make it easier for the operator to find those. You know, but the big piece of it was just get a little cart that the people had in the shop already, and just put the tools on it that you need to change out a car alarm. And then that way you can roll that right next to the car, and then you have all the tools and supplies needed exactly where you need them. It's something that's called point of use storage. And you know, just doing that one little thing saved a ton of time and frustration for this worker, because this worker didn't have to do any of those things, looking around the shop, walking back and forth from place to place, and the worker could concentrate on just doing a high quality job of installing that car alarm just right here in the location, in the Gemba, right in the location where that work needed to be done. All right, so let's take a look at our next process, and in this one, as we walk through it, I think I'm going to let you take a look at the video, then we'll pause, and I want you to think of where the non-value added pieces are. So where the non-value added is and where the value added pieces are. So I'll explain to you what's about to happen in the video. You'll watch a video, motion video happening, and then you'll see that I'm going to pause the video. When the video pauses, I want you to think about where you saw value added activity, and then I'll come back and I will tell you where I see value added activity. Yeah, then we'll have discussions about it. We'll go through a couple of different iterations of this so that you get practice seeing the value added and being able to see the waste. That's really the key to lean, is being able to see waste. So these little videos, it's not as good as being in the real Gemba, not as good as being in the real process right in the middle of where that work happens. But it's the best that we have here, being able to watch these videos. And so yeah, so we're going to practice being able to see waste in a process. All right, so let's take a look. All right, here's the next process. So I'll tell you, I love the story behind this process. So let me tell you, this was one of my students from a previous semester, and she was taking this class, and she came to me and she said, hey, I'd like to do a process improvement, and my dad owns a shop, owns a car mechanics shop, and he rebuilds transmissions. It's one of the biggest things he does. He just rebuilds transmissions all day, and I love to help improve his process for rebuilding transmissions. And I said, well, great. And so she showed me this video that you're about to see parts. I'm showing you parts of it here, not the whole thing. And when I saw the video, I saw the waste. And when I saw the waste, now I'll tell you, I've never taken apart, rebuilt a transmission. I don't know anything about it. I was talking with this student, and she said to me, she said, one thing that worries me is, she said, I've never spent any time in my dad's shop. She said, I don't know a thing about cars. I don't know anything about rebuilding a car transmission. And I said, it's okay. I said, as long as you can see the waste, and as long as you can teach your dad to see the waste, if you can see the waste and your dad can see the waste, then you'll be able to think of creative ways of improving this process to remove the waste. Because we're not going to be messing around with your dad's expertise at building, taking apart and rebuilding transmissions. What we're going to do is we're just going to eliminate the non-value added activities from this process so that your dad can do more of what he's really good at and what he really enjoys. And it was kind of interesting because her dad actually said to her before our little project began, he said to her, he said, sure, you can, help out if this helps out in your class, you're welcome to watch what I do and do your project or whatever on this. He said, but he said, you probably won't be able to improve things much. He said, because I've been building transmissions now for 20 years. And he said, I've already streamlined it, and gotten really, really good at it. So there's probably not a whole lot of improvement that you can make to it. And so you're going to get to see the process, and then maybe at the end I'll, kind of give you the punchline about how we improved the process. But I'm going to give you an opportunity to see if you can figure out what is value added and non-value added. So I'm going to show you a portion of a video clip, and then I'm going to pause the video. And when I pause the video, perhaps on YouTube, you could pause the video as well. Just press the pause key. I won't leave it paused for very long. And I want you to think to yourself, what did I just watch? And what pieces of that I just saw, what pieces of it were value added and what pieces of it were non-value added? And kind of get a good feel for that. And then I'll talk you through that. And so we can kind of calibrate our thoughts about what it is that's going on in this process. Okay. So that roundish sort of thing that the guy in the video has, that is the transmission. And so just like with the car alarm, what this guy needs to do is he needs to take apart the old transmission. He needs to take the worn pieces, and he's going to get rid of the worn pieces. The pieces like the fasteners that he can keep, he's going to keep those. There's some pieces in there that he can clean, but then he's going to get new pieces and put the new pieces into the transmission. So just like with the car alarm, anytime we are seeing something that is physically connected to the transmission that we disconnect from that transmission to open it up and take it apart, that is going to be value added. Anytime we are taking pieces and putting them onto the transmission physically, physically connecting the two pieces together again, that is going to be value added as well. And then everything else that you see in the video is going to be non-value added, right? So that's what we're going to talk through. So here, who is the customer? What do they want? The customer has a worn out transmission. They want a transmission that works properly, that works like a new transmission. The purpose of the process is to give us all brand new parts inside that transmission to make it work properly. And we have the old transmission, the old pieces. We have the new transmission pieces and fasteners. And the transformation is taking all of those inputs and connecting them together, connecting the new transmission parts onto that old transmission frame is the transformation that occurs. And in the end, we hope we get a brand new working transmission. All right, so let's take a watch at this video. I'm just going to let it go silent. It is running at like twice speed or 1.5 times speed, something like that. So it's going to move pretty quick, just so that you don't have to, watch through a long, boring video. But keep in mind, look for what you consider to be value added, and then let's see if we can identify that in a few minutes. All right, so were you able to see what was value added in there? So let me talk you through what happened. You might need to rewind and take a look at that again if you'd like to. First thing that he did was kind of readjust where that transmission was on the table. Then he got out, he's got the drill looking thing there that's used to take bolts off of the transmission, and he unscrewed the bolts out of the transmission, out of the big pieces there, and so it was only the back out motion of those bolts. So when he squeezed the trigger on his little gun there and those bolts backed out of the transmission, you probably noticed as he was pulling the bolts out, he would take them in his left hand and he would put them into a little dish or a tray over there on the left, and that'll be important for us later on. Now, the only part of that was value added was the bolt physically backing out of the transmission body. Him moving them over to that dish and actually pulling the bolts off of the thing were not value added. He then took there was a shroud or a cover, and he took that off and set that off to the side. Just the moment that cover disconnected from the original transmission was value added. The moving of that was non-value added. Now, it was interesting. What happened next was there was another set of bolts, and he loosened all of those with the drill. So he pushed the drill in and pulled those bolts out of there. And then what he did was then he set his little gun down, his little drill fastener tool down. Now, he has done the value added, actually backed the threaded bolts out of that transmission body. And next what he did was he reached into the body and he pulled the bolts that they were just sitting there at that point, and he pulled each one of them out and set them into that tray that is there on the left. And so the value added piece there was just when his little gun was actually backing bolts out of the transmission. Him reaching there and grabbing the bolts and pulling them out and putting them over on the tray, non-value added. Now, once again, he's got to do all of this stuff. So, it's like necessary work that he's doing. It's just that we're going to be very specific about what we're going to call value added and what we are going to call non-value added. Now, another thing that I want you to notice here is he takes all of those bolts, and you can't tell because we're not really in the Gemba, but I'll tell you, he takes all those bolts out, and all those bolts are different. So the size of the holes are different, or the depths of the holes are different. So they're all different types of bolts. He pulls them all out, and he puts them in that same dish over there on the left. All right? So they were all in the transmission. He pulls them out, which, the removal of them from that transmission body is value added. And then he puts them over in that tray. Now, that'll be key for us later on, because then he's going to be using those same bolts later on, and we're going to kind of see what happens with those. So I want you to keep that in the back of your mind, that he's got those things over there in that tray. Now you've got a bunch of different sizes of bolts that are all sort of jumbled together. All right, so what did you see there that was value added? All right, so he walked over to his tool bench, he grabbed another tool or something, came back over, lifted a part off of the transmission, and then he took that drill again and he removed some more bolts. And once again, only the removal of those bolts, when that drill is backing the bolts out of the transmission, only that part is value added. Notice here, if we're going to talk about the waste of motion, notice that he pulls the bolts out, and as he pulls them out, he sets them down. And you may not have been able to see this because it was going so fast, and also we're not there in the Gemba. But he takes the bolts out of the transmission and he sets them on the counter in front of him. And then once he gets all the bolts out of the transmission, then he reaches down and he grabs all the bolts that are on the counter and he moves them over to that dish that's over there on the left with where all those other bolts are. Okay, so he's double handling the bolts. He picks them up to put them on the counter, and then he picks them up off the counter and puts them in the dish, whereas he could have just taken them out of the transmission and put them straight into the dish, and he would have eliminated some pickups and set downs. And remember, as we talked about in the video lecture, when we're evaluating waste, we are looking at seconds of waste. We're just looking for where are easy places where we can remove a second here, a second there. So I realize it's not a whole lot of time, but seconds count. If we can start eliminating little seconds here and there from a process of non-value added activity, it's just going to save us a lot in the end, because all these little savings are going to add up. All right, so now in the next section of the video, he's going to be putting all of these bolts and things back onto the transmission. So at that point, he's done some cleaning, he's put new parts into the transmission, and now he's going to take some, he's going to take those screws and bolts and he's going to put the shrouds and things back onto the transmission. So I want you to see how that work happens. So that's the next step. And so as you watch, again, look for what is value added, and you know the tip here is it's the transformation. It's only when those bolts are being screwed, physically screwed into the transmission, are we looking at value, real value added activity. Moving parts around, lifting them around, making adjustments, that sort of thing, not value added. I'm not saying it's not necessary. I'm just saying we're going to define it as non-value added. All right, so take a look at this next piece of the process and see if you can find the value added. All right, so what did you see there that was value added, and what did you see that was not value added? Okay, so I'll tell you on this step of the process, when we're evaluating value added and non-value added, we've talked about these definitions of terms. We're going to understand who the customer is, what sort of value that they want out of the outputs to this particular process. We're going to talk about what the inputs are and understand what the inputs are and what the transformation is that transforms those inputs into outputs, and then we're going to look for that transformation, those transformation activities happening, and when the transformation happens, we know value added is occurring. If there's no transformation happening, then it's non-value added. And for these analyses that we're going to do early on in the course, we're looking at the operator, and we're trying to say, is what the operator is doing, is the operator's actions value added, or is the operator's actions non-value added? Okay. I will tell you that even once, and when we make those definitions, a lot of times, like putting a screw in to something, attaching two things together, are clearly transformations and clearly something value added is occurring. I will tell you though that a lot of times in these processes, it's not a perfect game that we play. There's some activities that happen, and it's kind of difficult to determine, is it value added or non-value added? Now, I'll tell you that being in the Gemba is very helpful for this, because what we can do is we can talk to the operator and say, well, hey, whoa, what did you do there? And what was that for? And what does it do? And is that something that can be undone? Are you just moving things, or is that an actual physical transformation that's occurring? What's kind of going on there? And we can kind of understand better to define whether it's value added or non-value added. I'll also tell you that in processes that I have evaluated in real companies that I've been a part of, kind of one of the rules of thumb, we'd be on a team and we'd be looking at a process like this and evaluating what's value added and non-value added. And we would come to a place where there was a disagreement. And, in here, there may be some disagreement between you and me about what is value added in this little piece of video that we just saw. Whenever we came to a disagreement, we would try to work it out by explaining our rationale for why something was value added or non-value added to one another. But if we couldn't come to an agreement, then what we did was we said, you know what, let's just call it non-value added. We would always kind of err on the side of calling an activity non-value added. And the reason for this is because the more things that we can find that are non-value added, the more things that are non-value added, the more opportunity we have to improve a process, right? Because we're not going to be improving the value added. I'm not trying to make the worker speed up or have higher quality on the value add. What I'm doing is I'm saying, how can we remove non-value added? So the more items we can put in that non-value added category, the more opportunity we have for improving the process. So that may apply here. So let's take a look. Now, the first thing that you saw is the worker walked over to the table, and you may not have been able to really see what was going on, but he stuck his fingers in a little tub of something, and it was grease. And so he brought over a little grease, and he put grease into this hole on the transmission. Then he walked back over to the table. He actually grabbed the little container of grease that you see, and then he dipped his fingers in and greased up some of the holes on the transmission. Now, that grease, that's a lubricant. It enables parts of the transmission to slide against one another. Anytime you have metal parts, you need some sort of a lubricant, an oil or a grease, to keep those things sliding against one another. And so that's what he did here on this transmission. Now the question is that a transformation? Am I transforming? Am I changing the transmission by putting grease on the transmission? And there's two ways to look at this. So you might say, you know what, that is not a transformation. All we're doing is we're taking the grease and we're just moving the grease to the holes on the transmission, but we aren't actually changing the transmission, because I could just take the grease and wipe it off of the transmission, and I've sort of undone what I just did. And so I didn't really permanently physically transform that engine, that transmission. Didn't transform it. I just moved the grease from place to place. If that is your perspective, then putting the grease on the transmission is non-value added. If you say, though, that putting that grease is part of the inputs that is being transformed, and that you're actually coating these metal parts to transform the metal parts from a metal part that is not slippery into a metal part that is slippery, and the grease is the mechanism to make that happen, then when you put grease on the transmission, you're changing the transmission into a slippery transmission. And by changing it, that is that transformation. And so if that's your perspective, then putting grease on the transmission is value added. Okay, and so you could call it either thing. I will tell you, for this particular process, I would probably say, part of what the customer wants is once the metal parts in there that slide next to each other and don't rub on each other and don't cause friction. And so putting the grease on the transmission, changing it, making it slippery. That grease, I don't know if you've ever dealt with grease, but it can be really hard to take off of surfaces once you put it on. So I think putting the grease on the transmission actually is a transformative step in the process. So I'm going to call that value added. All right, so now the next thing that occurs is that the operator, the worker, takes some sort of a metal pin and places the pin into the hole and then bangs on the pin to get it to go down in the hole. Every time the worker bangs on the pin, that is value added. So he slammed down with his hand, bam. Okay, that little bam, that was value added. Then he did it again, bam, another value added. Slammed it again, down again, bam. So each one of those slaps is value added, not when he lifts his hand, just when his hand goes down. Okay, so those are value added. And then the worker takes the shaft of the transmission and rotates it around, and what he's doing there is making sure that he has put that pin in far enough. If he doesn't put it in far enough, then the transmission won't turn. So he's turning the transmission to make sure he put it in far enough. And of course, that's an inspection. He's not actually changing the transmission there. He's just checking to see if it's correct. So slamming the pin in, definitely value added. The adjustment to the transmission, the turning of the shaft to check to see if that pin's in far enough, not value added. That is part of an inspection to make sure that he's got it installed correctly. I'm not saying he shouldn't do that. I'm just saying that we're going to classify that as non-value added. All right, so now let's watch the operator put some parts, put some screws in on this transmission. All right, so what did you see there that was value added? All right, well, let's see. The first thing that the operator did is took that cone sort of thing and put it up on top of the transmission. Now that's one of those parts that, we kind of have to be, is that value added or not value added? I mean, he really is just taking the cone and moving it to the transmission and just setting it up on top. He's not really attaching it at that point. So I don't know, and that's up for debate. I would probably classify it as non-value added because we didn't actually transform the transmission. We just moved that part over. We didn't really attach it. But I don't know. I'd have to talk to the operator and see kind of what I think. But then walks over to the bench, and you notice there, well, while you can see him standing over there by the bench right there, and you see he's got like a little red tray or red cloth there that's on the table, and that's got all those fasteners in it. So you remember the fasteners that were in the tray? So now all those fasteners are dumped out on that red cloth, and when he goes over there, he kind of sorts through them, shoves them around to try to figure out, well, which ones do I need next? And so he gets the ones that he needs next, and he takes them over. So then he got a few of those and brought them over, placed them on that cone, and then he tightened those down. So the tightening down of those bolts, definitely value added. And then he changes the orientation of the transmission. He puts another piece on. And again, I think probably, I don't know, that next piece that goes on, you'd have to go back and take a look at the video. That might be more likely to be value added. So here's some, some of these like sliding pieces on, is that value added or not? It's debatable, okay? And I'm okay with a little bit of vague in there. That's all right with me. This one, that metal plate that he puts on the front seems to fit a little bit more tightly, where it actually is a fit sort of a thing, and so he shoves it on there. Again, it would have to be something that you would be in the Gemba and actually feel and see to see whether you feel like that's value added or whether it's just transportation motion. But then he walks over to that bench, picks up the fasteners that he needs. He actually goes back over there a couple of times. He comes back over, makes some adjustments, and then he just drops the fasteners into the holes. Dropping the fasteners into the holes, not value added. That's just moving the fasteners over there. The only thing value added on those fasteners is when he takes that that gun of his, that pneumatic drill sort of a thing, and tightens those bolts, which he hasn't done yet, but you're getting ready to see him do it. Okay, so then we'll watch the last little part of this video that we're going to see for today, and see if you can figure out what's value added in the last piece of this. So let's take a look. All right. So in this last part of the video, you see him walk back and forth a couple of times, and then he tightens up the bolts again. You'll notice that he's tightening up the bolts with that drill, and then he gets a phone call, which distracts him from his process, and he sort of goes away from his process. He comes back with that drill. While he's talking on the phone, he kind of hand tightens a few of those bolts, but then he has to go back to those bolts and tighten them down with the drill. Okay, so that's one example of over processing, where he's tightened down a bolt and then he tightens it again. Same thing at the toward the end. Now, let's see. At the end, he's got something that's called a torque wrench. So he uses the pneumatic drill to tighten those bolts down, each one of the bolts down. Then he takes this stick-looking wrench and he hand tightens each one with that. And I'll be honest, I don't know what that is for. So that's one of those things where I'd have to ask, well, what's the purpose of that? Why did you use that tool in between the wrench? And I know what the last one is. The last tool he used there was called a torque wrench. He was pointing on their little graduations. What that does is it makes sure that the bolts are tightened exactly to the tightening specification for that particular bolt. So with that torque wrench, part of it is an inspection, but part of it is also that torque wrench will tighten a bolt and get it to the tightness that it actually is. So I'm okay calling that value added. Let's think through this a second. Okay, it depends on what is happening in the Gemba. All right, so let's think through this. If the operator takes that torque wrench and is trying to check to see if each one of the bolts is tight enough, and the torque wrench indicates that each bolt is exactly the tightness that it needs to be, or at least as tight as it needs to be, then what the operator is doing with that torque wrench is just an inspection. All right. But if the operator is using that torque wrench and actually finds bolts that haven't been torqued to the right torque, to the right tightness, and is using the torque wrench to further tighten the bolts down to the proper tightness, then that would be considered a value-added activity. Okay, so this is one of those that could be debatable, and it depends on what you find in the Gemba. One thing that I noticed here in the video, though, is that because the operator gets a little distracted with his phone call, then he ends up tightening a couple of the bolts twice. That is an example of over-processing. You tighten the bolt once, and now you're having to tighten the bolt again because you lost track of where you were. So there we've got all of the value-added, non-value-added. So in all of this stuff, in taking apart and putting back together the transmission for the parts of the process that we saw, for the most part, now we would have to go through and really detail out what the value-added pieces are, and there aren't that many of them. Most of the value-added pieces are tightening of bolts or removing of bolts, loosening of bolts. There were a few seconds that were in there in the process where we were taking apart and putting it onto the transmission, or taking apart and taking it off of the transmission. Okay, so there were a couple of those, but then there was a lot of non-value added. So think back, where was most of the non-value added occurring? And this is one thing that we would write down. Where's most of it happening? And most of the non-value added happened, walking back and forth to the bench, trying to get that drill. The drill was set down in different places, and the operator had to walk back and forth for that, having to walk back and forth to that bench where the fasteners were. They were all the way, several paces away. And then at the fasteners, part of the value added was sorting through, kind of moving your hands around, trying to find the right fastener to put on the transmission at the right time, because they weren't organized over there. They were just kind of, all those fasteners just kind of over there in a pile. So now I want you to think, in fact, you can pause the video if you want to. I want you to think, what are a couple of things, and for most of you, you're probably like me, you don't know really any of the details about what this operator is doing. You're just looking here and identifying value-added, non-value-added based upon our definitions. But already looking at the process, what are some things that you might suggest that would help to improve this process by removing non-value-added? Can you think of anything? So I'll tell you a couple of things that this team did, which helped out a lot. So one thing was, instead of having the workbenches all in a row so that the operator had to walk several paces to go get tools, they put the workbenches in an L shape so that the worker was working right in the middle of the workbenches. So all the worker had to do was turn around and there was the workbench. Okay, so that was one thing that they did. The other thing that they did was they created a tray that had little dividers in it. And the little tray with the dividers, each one of the different bolts that were different sizes would go into a different compartment on that tray. So as the worker took bolts off of the transmission, the worker would put the bolts that were the same in the same little compartment in the tray. And then that way too, when the worker was putting the transmission back together again, all of the fasteners were already separated out by what type of fastener it was to make it easier to go grab the correct fastener. Now, the putting down of the fasteners and the picking up of the fasteners is still non-value added, but it's just that there's less time, and it made it a lot easier for this worker to do this. Now, I'll tell you, you can watch the actual improvement video on YouTube. I have it on my Real Student Improvements playlist on YouTube, so you can take a peek at that, and it's in there. And you'll notice, I think that in this process, they actually they reduce the time it takes to take apart and rebuild a transmission by 60%. And they didn't spend any money. It was all just by, moving a bench here, organizing the tools in a certain way, creating that little tray for each one of the fasteners. And they took 60% of the non-value added out of this process. I just think that's amazing. And so, of course, the owner of this business, who, the student's father, thought it was just amazing that his daughter was able to come and coach him through improving his process by 60%. He actually wrote me a letter and said, I'm going to take these principles and use them everywhere in my shop because this is just amazing. All that stuff that I was doing was just useless and it was waste. And I found ways of getting rid of that waste. And that's the biggest part of lean improvements. And you can make amazing improvements just by removing the waste out of those processes. Okay, so here were a couple that kind of manufacturing type examples. Let's look at one that maybe is a little bit closer to home. Let's watch the process of cooking a meal in a kitchen. All right, so now we're going to watch a video of cooking a meal in a kitchen. Now, your kitchen probably looks a lot different than this student's kitchen. What you cook is probably different than this student's meal that they are cooking. But that's not important. This really is a gemba that you're familiar with. You have a kitchen that you're familiar with. You have a gemba that you go to, and then you have meals that you cook in that kitchen that are important to you. And so let's talk through, the same sorts of stuff that we talk about for all processes. In order to evaluate what's value added and non-value added, we need to answer these questions. So who is the customer and what do they want? So, now I don't know exactly who the customer is for this particular meal cooking process. I suspect that part of the customer is this student themselves. They may be cooking for their family, maybe cooking for a relative, maybe a little brother or sister. And so, these are the customers. The customers are the people that are going to be eating this meal. And what do they want? Well, so they're going to want a lot of things. Think about what you want when you eat a meal. You're going to want something that is nutritious, something that fills you up, when you're hungry, something that tastes good. So, there's some sort of quality aspect to it. And although you're probably not, putting some special garnish on the plate and making it look really fancy like at a fancy restaurant, there probably is some sort of presentation for the food that is some level of presentation that's important for quality as well. So, think about, there's all of these different aspects are involved with the nutrition of the meal, those sorts of things. Okay, so those are the things. And then speed also, especially if you're really hungry, the sooner you can get this, the better. So all of those things are going to create value for the customer. So what is the purpose of the process? So let's describe the inputs and outputs. So the inputs to the process are the various ingredients that the student uses. So you'll see there's some spices and some different ingredients that the student pulls from different places, cabinets and drawers and, the refrigerator, of course, different places, pulls them out, and then the transformation that what they're doing is they're taking those ingredients and they are blending those in unique ways, and changing those individual ingredients into a meal that is a cohesive meal that kind of has all of those different flavors in it. So anytime we are taking an ingredient, a food ingredient, anytime we're taking a food ingredient that is a part of this meal, and we are taking and we are physically changing that ingredient. So if we're changing the form of it, changing, permanently kind of changing the form that it's in, the shape that it's in, changing the how it's flavored, or the different ingredients that are blended together, the blending of them or the heating of them, chemically changing these ingredients. Anytime we are making a permanent change to these ingredients, then that is a value added activity. Okay, that's value added. Everything else that you're going to see in this process is going to be non-value added. So, what is being transformed? It's those ingredients, the ingredients of the food items there, and they're going to be transformed in a variety of ways, by cutting them, or by blending them together, or mixing them, or heating them up in some way. Okay, so those are the transformations that are going to be occurring. All right, so let's watch. And again, we'll do it the same way. I'll let you watch a portion of the video, and you tell me what you see in there that is value added, and of course everything else is going to be non-value added. We'll pause the video, and then you will have an opportunity to tell me what it is that you see that's value added. All right, so let's take a look. All right, so out of all that, what did you see there that was value added? Okay. And you would be correct if you said nothing. Nothing was value added. So this student has not done any transformation yet to cook the meal. The student went over to the refrigerator, looked around, moved some stuff around in there, brought out some eggs, found a bowl, found the utensil, found a bag, put things all together, in this one area. But the student has not transformed any ingredients. The student just has a bowl and eggs and stuff sitting out on the counter, but no transformation has occurred. So no value added yet. Okay, lots of walking, lots of transportation, some motion there, especially at the refrigerator, looking around for stuff, but nothing that is value added. All right, so let's keep watching. All right, so what did you see that was value added there? All right, let's talk about some of the different parts of this process. So the first thing that you saw is that the student cracks the eggs. Okay, so that value added. Now it's It's value added when the student takes the fork and smacks the fork against the shell of the egg and cracks it open. Okay, and possibly when the student pries the shell away from one another so the egg drops in. But dropping the eggshell, cleaning up after, rinsing off of her hands, all non-value added. The only thing value added is cracking those eggs. Okay, so really not very much time there. Then the student takes the fork, sticks it into the bowl of eggs, and whisks the eggs. Okay, so let's talk about this whisking here for a minute and what happens there. Okay, so when you whisk eggs, and I don't know if you've ever done this before, but when you sort of whisk eggs around, the eggs have the white part and then it has the yolk, and what you're doing there is you're breaking up the yolk. This is where being in the gemba really helps, understanding, doing it yourself, or really talking to the operator and being right there to see what's going on. But you're breaking up the yolk, and then you're kind of breaking up the white of that egg, which is kind of I don't know how to describe it. It kind of sticks to itself. So as you whisk through it, you're breaking up those fibers, and you're getting the yolk to mix in with the white. So the yellow and white kind of mix together, and that's why you have this yellow mixture here at the end. And of course, the breaking up of all of those components of the egg together as you're whisking it is certainly value added. Okay, so I'm okay with that. The rotation of the fork inside the bowl, the whisk, definitely value added. Now, there is a question, and so you would have to be in the gemba to answer this, and I can't answer this from watching the video, but you could by being in the middle of that process. Part of the question that you need to ask is, at what point are the eggs mixed up enough? So, you can imagine I'm going to whisk the eggs. Well, so when do I stop whisking the eggs? When does whisking the eggs change from being transformation, a value-added transformation, to being over-processing, where I'm whisking the eggs, but they've already been whisked enough, and I'm just whisking them again? Okay, and so I can't answer that from watching the video. I'm just saying in the middle of the gemba, and in your gemba, that would be something that you would need to consider. We'll talk more in another class about standard work and creating work standards, but perhaps there's some standard of the amount of whisking to make the eggs whisked enough so that the quality is top-notch of this food dish. You never want to eliminate value-added work because that's going to degrade quality, and we're not going to do that. We want to have very high quality, but there is some point where you're whisking the eggs and you've whisked it more than enough. So what is that point? And I don't know what that is here. Okay, so then the student takes the bowl and carries it over to the other counter. Not value added there. That's just transporting it, moving the eggs. The student gets out some spices, 2 different spices, not value added. The student adds 3 spoons of the first spice and 2 spoons of the second spice. Okay, now the only thing there that is value added is the moment that the spice hits the eggs. Okay, because until then, the student is just transporting the spice, right? They put the spice in a spoon and then they're just moving the spice, but that doesn't transform the spice. Only the moment that the spice hits the eggs is transformative. Now, here's one thing, you can think of this already just looking at it. The student reaches into the spice container, not value added, gets a spoonful of spice, not value added, pulls that spoonful of spice out of the container, not value added, moves the spice over to the eggs, not value added, drops the spice into the eggs, value added. Okay? Then the student does that again. Then the student does that again for that one spice where she used 3 spices there. Can you think of a way she could have removed a lot of that non-value added? And there's probably more than one way to do this, but one way is to use a spoon that is big enough, is the size of 3 of her little spoons, right? Use one spoon that is the size of 3 of those little spoons. That way, when you reach into the spice container and you pull out the spice, all that's still non-value added, but you only have to do it once instead of doing it 3 times. Okay? So then the student puts that into the bowl, then puts those 2 spices in, and then whisks the eggs. Okay, so takes that that fork and whisk the eggs. Now, the whisking of the eggs there is mixing the spices, getting the spice completely blended into the egg. And so again, that whisking is value added. Whisking it up is taking that spice and blending it throughout the eggs. And so then there's the same question of, well, when is it blended enough? And how do we know that it's blended enough? And I don't know the answer to that question without being there. There's another question that we might ask here. Okay. So when I am whisking the eggs the first time, I'm breaking up the fibers of the eggs so that the yolk is mixed in with the white. And then when I whisk the eggs the second time, I'm whisking it so that the spices are mixed in with the egg. And one thing that I'm wondering, and perhaps we might experiment with this, is me whisking the eggs here with the spices, is that over processing of the eggs? You know, I whisked them one time, and now I'm whisking them again, and it just makes me wonder. I wonder if I'd get the same quality out of the eggs if I just put the eggs into the bowl and then put the spices onto the eggs and then just whisk the eggs and the spices all together, and then I only have to whisk them once instead of whisking them twice. Again, I don't know without talking to the operator. I don't know without doing it myself. I don't know without experimenting myself with this. Okay, so I can't definitively say that one of the whisking is value added, but the other of the whiskings is over processing. That would be something that we would have to determine in the Gemba, but I do think it's interesting to think about. Okay, so now let's watch this student again continue to cook this meal. All right, so what did you see that was value added in there? Again, a lot of looking around for things, a lot of motion waste, transportation waste, walking back and forth, back over to the fridge, and forgetting things and not knowing where things are, and then bringing things over. And really, the only thing that the student did that was value added was the moment the cheese hit the egg mixture, right? Because then that changed the cheese. Once the cheese hits that egg mixture, you aren't putting it back in the bag, right? It's changed. It's now drenched, coated in egg. And then, of course, she whisks again. And we've talked about, so is that whisking value added? It does mix the cheese in with the egg, but, does that mean that the other whisking that we did earlier, we didn't really have to do as much of? I don't know. Again, so that's an experimentation thing that we'd have to mess around with. But really, the only thing there that was value added was the putting of the egg into the, or putting of the cheese into the egg mixture, and then, the whisking there. We talked about that whisking may make some of the other whisking redundant, but that's where it is right now. All right, so let's see what's next in the process. All right, now we're getting somewhere. Okay, so look in there. What in there was value added? All right, so she goes over to a cabinet. She looks through all of the pans that she has. She finds the right pan. Okay, so all that's waste of motion, carrying the pan over to the stove, transportation. She sets the pan down on the stove, and then she turns on the stove, turns on the burner on the stove so that she can heat up the pan. I think she's going to make an omelet of some sort. And so she's going to cook the omelet in the pan. The pan needs to be hot for her to cook the omelet. So she turns on the oven to heat up the pan. And so the oven, or that stove's going to get hot and heat up that pan. So what was value added there? Okay, now this goes back. This is why I say it's important to ask these questions at the beginning. You need to ask these questions and understand who is the customer, what is the purpose of the process, what is being transformed, what are the inputs being transformed into an output. You have to understand that in order to determine what is value added. All right. What is she heating up right now on the stove? She's not heating up anything. She's heating up the pan. Okay. Is the pan one of the food ingredients? Nope. The pan is not the food ingredient. The customer doesn't want a hot pan. The customer wants a hot omelet. They don't want a hot pan, right? So heating the pan is not value added. So this student has not done anything value added here by turning on the stove and heating the pan. And you might say, well, wait a minute. You got to heat up the oven to heat up the pan because you have to have a hot pan to cook an omelet. You're not going to cook an omelet without a hot pan, so you have to do it. It's necessary. You're not going to, if you have a cold pan, you're not going to have an omelet. And then the customer won't like it. So we have to heat up the pan, so it's value added. No, it's not. It's not value added. Just because we have to heat up the pan doesn't make it value added. We're heating up the pan. The pan is not one of our food ingredients. The purpose of this process is not to heat up or to cook the pan. It's to cook the omelet. So heating up the pan, not value added. Okay? So far, nothing in that, in that little segment that we just saw is value added. All right, let's see what's next. All right, so now we're making some toast. So what's value added here? So walking over, getting the toast, finding the bags, not finding the toast, but finding the bread, getting the 2 bags of bread, pulling them out, not value added. Opening the containers of the bread, not value added. Taking the slices of bread, putting them into the toaster, not value added. Okay, putting the bread away, putting it back in the bags, putting it away, not value added. The only thing value added there, the thing that's going to do the transformation is when the toaster is hot and the toaster is toasting the eggs. Now this is an automatic operation, and so in an automatic operation like this, what we're going to say is that the moment that you get that operation beginning, we're looking at what is it that's value added by the operator. So the moment that the operator initiates that value added, the machine to do the value added work is value added. So the only thing value added here is when the student pushes the button down to start the toaster. So the moment that the button on the toaster goes down and the toaster begins is value added. It's going to be the same thing, if let's say you preheat an oven and then you're going to put a casserole in the oven. Moving the casserole over to the oven is non-value added, but we can say that the closing of the door of the oven perhaps is value added because that's where you initiate that cooking. But then the process is automated from there. So we're looking at what is the operator doing that's value added. Or if you're making a microwave meal, you take the microwave meal and you puncture the top and peel the top off of it and take it over to the microwave and put it in. All that's non-value added transportation. You close the door to the microwave, not value added. You press the little buttons to tell how long to microwave, not value added. But then you press the start button. Okay, the moment you press the start button, that is value added. We'll say that that's value added because you're initiating this automated process. You have an automated piece of machinery that's working, and you, the worker, are initiating that, and we're going to call that value added. Okay. So in this toast making process, the only thing value added was the pushing down of the buttons. The getting of the bread, putting the bread, taking the bread out, taking the packages apart, putting the bread into the toaster, putting the bread back in the bags, taking the bread back where it belongs. All right. Now look, in this process, can you think of something that the operator or that the student could do to shorten this process? To remove some of the non-value added here, just with the toast, just with dealing with the toast. There's a couple of things that you could do, and it wouldn't cost you anything, and it wouldn't, make the kitchen look messy or be, weird in the kitchen. Can you think of anything? Well, one thing that you could do is instead of storing the bread on the other side of the refrigerator, you could store the bread right next to the toaster, right? Now look, in your kitchen, you might not like the bread, on the counter right next to the toaster. Well, that's fine. I mean, couldn't you keep it in the cabinet right above the toaster? That might work, right? Notice that in order to make the toast, she had to walk across the kitchen to get to the toaster. Perhaps there's a better place to put the toaster where when she makes an omelet, she wouldn't have to walk as far to make the toast to go with the omelet. And then keep the bread next to the toaster. So this is a principle. I mean, this is pretty common, and we're going to use this a lot. This is called point of view storage. And point of view storage means that if you've got, ingredients or you've got inventory that is used in a process, then store it where it's used. Okay? If you have a tool, you have a tool or piece of machinery that is needed to do a transformation in a process, store it where you actually use it, or store it, store equipment that is used together, store the equipment that's used together. So that when you use one, the other one is right there. So you don't have to go walking around, right? And all that's going to do is just remove the non-value added. I'm not asking this student to cook faster or, don't toast it as much because it takes too long. Or run. You should run it around the kitchen. I'm not saying that. I'm just saying, why don't we just store things where we need them? Right? Eliminate simple things to remove that non-value added. All right, so let's watch the next piece of the process. All right, so now what's value added? So she opens the container of the butter. That's not value added. She gets a fork or a knife or whatever that is and takes out some butter. Well, that's not value added. She plops the butter into the pan, and the butter begins melting in that hot pan. That is value added, right? That's value added. I guess, before she even did that, she came over to the pan and she put her hand over the pan to see if it was hot. You remember that? What was that? Was that value added? Well, it wasn't transforming anything. That was an inspection. She was checking to see if the pan was hot enough, right? All right. Then she looks around for a spatula and can't really find a spatula. Looking around. Eventually she finds one. She swirls the butter around and moves it around with her spatula. Now the swirling of the butter and the moving around with that spatula, again, that's one of those things. You got to be in the middle of the gemba. I suspect, because I've made an omelet before, I suspect that what she was doing there was melting the butter. And because you take that butter, and if you can spread it around the pan, then it will melt faster. So she was working to try to get that butter to melt faster and be spread out across the omelet pan, so when she puts the eggs in, it doesn't stick. Okay. So she's melting the butter in that pan. And so the melting of the butter, the active work that she does to melt the butter in the pan, I'm okay with calling that value added. She's doing some mechanical swirling and moving of that butter to make it melt, and I'm okay with that. All right. Okay, let's keep watching. All right, so now what's value added? She takes those eggs, she puts them into the pan. Okay, now as soon as the eggs hit the buttery hot pan, then that moment is value added. She has taken and mixed those two together. She's taken those eggs. They are no longer just eggs. They are now eggs mixed with hot butter, and they are starting to be transformed by that pan. Okay, but just that moment that the eggs go into the pan is value added. Now, this is another one of those things you have to learn from being in the Gemba, from actually cooking your own omelet. She takes the spatula and sort of runs it across the top of the eggs. From what I saw there that she did, there wasn't any value added. Okay, she really didn't move around the eggs. She just kind of ran that spatula across the top of the eggs. And really the only thing she's doing is waiting for the pan to do, that hot pan to do its transformation. So at this point, it's kind of automated. And so she decides, which is just fine, she decides to find some other activities to do. They turn out to be non-value added, but she goes over and she gets a couple of plates. The toast is done by now. She grabs the toast, she puts the toast on the plates, she moves the toast and plates over to the counter. Okay, but all of that's motion transportation. There's no value added in that. The only thing value added so far is that she plopped the eggs into the pan. Just that moment that the eggs plopped into the pan. Okay, now let's keep watching, see what happens next. All right, and then she finishes the process. So what in there was value added? Okay, well, she was cooking those eggs, and she was taking the spatula. And if you've ever cooked eggs before, you kind of know how this works. She was swirling the spatula around in the eggs to break up the eggs, and the parts of the egg that are turning hard, that are actually cooking, is the part on the bottom. So she was using the spatula to flip the egg pieces so that the cooked part went on top and the uncooked part went on the bottom to cook the eggs all the way through. All right, so that flipping was value added. Now, how much of that stirring and that flipping was value added? I don't know. That would be something where you would have to be in the Gemba. Preferably, you would have to be in the middle of that process. So you would have to be the one cooking the meal. And if you were the one cooking the meal, it would be up to you. You could probably make that determination better than me looking at a video about whether or not that's value added or not. How much of that flipping and cutting and swirling of the egg is value added. But then once the egg is cooked, moving the eggs over to the plates, non-value added, right? That's just moving them. She goes into the refrigerator, she gets some salsa, and that's not value added. She takes the salsa and adds several spoonfuls to the eggs of one of the plates. And as soon as the salsa hits the eggs, value added. Okay, I think there's several spoonfuls that she does there. She could have just done one larger spoonful, and that would have accomplished the same thing. But she puts that on the one egg. As soon as the salsa hits the egg, value added. But everything else is just motion transportation, right? Okay, so now, best thing really would be for you to pause this video. I want you to think, how could you reconfigure this entire process to remove a lot of the non-value added? What could you do there? And it won't be perfect, and I'm going to come up with a suggestion here too. And it might be different than yours. It doesn't make mine right and yours wrong. It's just different. But I just want you to think about, leave the value added alone. Don't try to speed up the value added, but think about all the non-value added pieces. In this process, if we were evaluating the value added and non-value added, we just go in and we pull out, what are the value added pieces? Well, the value added pieces are, let's see if I can remember them all. I have to look back at the video, but I believe it was cracking the eggs, adding spices, whisking the eggs going into the hot pan, and pressing the button down on the toaster. I think that was it. That was the only value added thing. So it's just a matter of, how do you organize that work so that we can do the value added, but we don't have to do so much of the non-value added. So go ahead and pause. Think about that for a minute. And I'll give you my suggestion. Okay, here's what I would think of. I might suggest reordering the way the kitchen is organized, one thing, and then reorganizing the order in which I do the tasks. So, I would probably suggest keeping the toaster and the bread over by the stove, okay, right next to the stove. Then what I would do is, in the fridge, you notice, these are things, the eggs and the butter and the salsa, those are things that she pulls out of the fridge. Those things, I'm guessing she uses those for eggs quite often. I might store those right next to each other, or I might even get like a little bin, a little box, and put those things in the box, put those in the fridge, so that when I go to the fridge, it's easy for me to pick all those things out together. Okay, that might be something I do. The other thing I do is I probably have the spices for the eggs. Probably keep those. You could even keep those right by the bread, or keep those in a little container. So that, because those are the egg spices. I don't know. It depends on how she uses them. But I'd keep those together so that the spices that are used together are stored together in a location that's right next to the where they're needed. That omelet pan that she has, instead of storing it across the stove, across the kitchen from where she uses it, I would probably store it right next to the stove. There's probably a drawer or a cabinet where that little pan can go. You could even put the spices that are used for the omelets inside of the omelet pan, right? And then when you pull the omelet pan out, and you keep the spatula in the omelet pan. Then when you pull the omelet pan out, it's got the spatula, it's got the spices in there already, right? So that might be something I do, right? And that's just where I store things. I could just store them there. Then here would be kind of what I'm thinking the process would be. I might start out, and the first thing I do is pull out the pan. And pull out the pan with the spatula and the spices. Pull that out. Set the pan down on the stove, and go ahead and start the stove. That'll be first thing. Okay. Then I'd probably go over to the refrigerator and get my box of stuff out of the refrigerator that has in it the eggs and the butter, and maybe the salsa, right? And I bring that back over to the stove. So there's going to be some walking transportation there. But while I'm doing that, the pan's heating up. First thing I'd probably do is take the butter out and go ahead and put the butter into the pan so that the butter can start to melt in the hot pan. Then while the pan is heating up and while the butter is melting, I would crack the eggs, put in the spices. I wouldn't whisk yet. I'd just put crack the eggs and put in the spices. And then after all the spices are in, I'd whisk it till it's done. I suspect that by that time, the the pan is hot and the butter's melted. I would then put the egg mixture into the pan. And then I would get toast started. And I'd put the toast in the toaster and get that started. I suspect that by the time the eggs are done, the toast would be done. And I could immediately put the eggs, store the plates over there by the stove, right? Because you need them by the stove anyway. So store the plates by the stove. And then I just have the plates there, put on the eggs, the toast is right there, lift the toast off, put it in, put the salsa on the one, have a big spoon to salsa, just the big salsa spoonful. And I don't know how much time that would save, but I suspect, I'm guessing, I honestly, I think I could probably save 40% of time cooking this meal by doing that. And the person cooking, it'd be easier for her. And she wouldn't have to work as hard or as fast. And it'd be less frustrating. All right. And that's lean. That's what lean is. That doesn't mean that this process doesn't have any more waste. It just means I saw the waste that's in it and I did what I could to remove the waste. Now, we would then look at the new process. This is the river and the rocks, right? Then what we would do is look at the new process and we would evaluate what's value added, what's non. And I would look at the non-value added then and I'd try to remove the non-value added there. Okay? Am I ever going to get this process to the point where there is no waste at all? It's only value added? No, I'm never going to do that. That would be the ideal state. But that's why we're always improving. That's why I can always make changes and little bitty tweaks of where I store things, how I use things, the order in which I do things. And the only reason I'm doing that, I'm just doing it to remove the waste. I'm not trying to do the value added faster. I'm not buying an egg making machine. I'm not buying the more expensive eggs that are already cracked and mixed, right? So I'm using the ingredients. I've still got high quality on all my ingredients and my cooking processes and my transformations. The only thing I'm removing is the non-value added waste. And this is the heart of lean. If you can do this, you can do lean. You can improve processes. Amazing. Like this one, I really think that I can improve this process 40% just doing some little things like that. All right, so let me teach you a tool. So this is a lean tool, lean process improvement tool that you can use to diagram out a process, evaluate it, and then begin improving it. It's called a spaghetti diagram. It's actually really, really simple. And for your next application assignment, you're going to be doing a spaghetti diagram of your own of a cooking process in your kitchen. So I'll walk you through the process here. Now, the thing that a spaghetti diagram is designed to do, it's designed to make the waste of transportation visible so that as the worker is walking around in the process, you're able to see it a little bit more clearly. And then it can give you a little bit of, it could do two things. One, it will demonstrate just how much walking is actually going on in the process. And the other thing that it will do is it'll give you some ideas about ways that you can streamline the process to remove some of that walking. Remember, walking around in the process is completely non-value added. So if you can just find ways of removing the walking by storing things in more convenient locations so that the person doesn't have to walk, then then you've really improved the process. You can really remove a lot of non-value added that way. So here's how you create a spaghetti diagram. Get out a piece of paper and you draw an overhead layout of the workspace. You're going to label everything on that layout. So what an overhead layout looks like, it's as if you are standing above the work area, looking down on top of it, and then you draw out tables and chairs and different machines that you have or storage locations for items, and you label all of those things. So that's the first step. Then you get the piece of paper with this layout. You get it out and you get a piece of a pencil or a pen, and you set down the pen on the piece of paper wherever the person that is doing the work is walking. So if you're the one doing the work, you would have to get someone else to draw the spaghetti diagram for you. And then if you're watching someone else, you would actually do this. And you just put the pen or pencil down on the paper. Now the rule with the spaghetti diagram is that you just follow the person around the process, and you just never pick up on the pencil or the pen. Follow them around wherever they walk. You draw a line. It's as if they have a little trail going behind them on this diagram. And at the end, of course, it looks like a bunch of squiggly lines on the page, which looks like a big mess. But that's why it's called a spaghetti diagram, because it just looks like, a plate of spaghetti with a bunch of lines drawn all around it. But then you can show this to the worker, you can look at it yourself, and you can see that there's actually a lot of waste involved in the walking around in that process. And then, after you do that, then you can figure out, well, where are they walking? How often are they going places? And what could I do to remove some of the walking out of this process? Because walking is non-value added. Okay, so let me show you what I mean. So step one is to draw an overhead layout of the workspace. So let's take a look at the overhead layout for the workspace of the kitchen video that we just saw. All right, so here is an overhead layout of this work process. So now I sketched this out with a ruler and a pen and drew some icons on there for the sink and the stove. You don't have to do one with such straight lines on it, though. If it works for you, I actually did this with in Excel and kind of created cells that were that size, and then did the highlighting around the cells to create this. But you don't have to do that for your process. When you create a spaghetti diagram, it's supposed to be quick and easy. So this is in real business processes. For real business process improvement, typically we don't draw it out really neatly. We really do just grab a sheet of paper and we sketch out an overhead work layout. Now sometimes in a work setting they actually have drawings of work areas that are already put together that make it really easy. But if you don't have that, you literally just get a pencil and paper and sketch out the overhead layout of the work area, and you label where the different items are. And so this is an example of one, and so you have that here. Now, one thing that if you want to try this out yourself here before you have to do it on your own, then print out this slide on one piece of paper, and then get out that piece of paper. And what I'm going to do next is I am going to insert the entire video of that cooking process that we just saw. Now it's about 5 minutes long. If you want to create your own spaghetti diagram, then here's your opportunity to try it out with this video. If you just want to watch, if you want to review the video, or you just want to see my drawing of the spaghetti diagram, you could just fast forward in the video about 5 minutes after this and you'll get there. But I wanted to give you that opportunity to see the video in its entirety so that you could create the spaghetti diagram. Now what you'll do is you'll get a pen, and the operator starts, or the person in this kitchen, she starts about right at the fridge near where that toaster is, right in that little corner. And so you can set your pencil right down there, and then as she walks around the kitchen, you just follow her with your pencil and you'll draw the lines. Wherever she walks, you draw a line on the paper. And yeah, so let's take a look at it. All right, so here are my spaghetti diagrams. The one you see on the left is the before picture. If you did this exercise with me, yours should look very similar to mine. It's just a bunch of lines going everywhere, and I really did this. I watched the video of her cooking that eggs and toast and drew lines wherever she, walked. And can you imagine if I were to take this diagram and then show her this and say, look, this is all the walking. You walked this far. We could actually measure this, measure how long each one of the lines are compared to, how long it is in that kitchen. I mean, she walked a long, long distance in order to make that egg and toast breakfast, I guess it was. So then I suggested in the video a few minutes ago, and I'll remind you what I suggested. I suggested some changes of the way that we organize the kitchen and the order that we cook the meal. And if we do this, then we should get a much more streamlined spaghetti diagram. Now, there's still waste. There's still walking. You notice I still have to go from the fridge all the way over to the stove. There's still all of that walking. Not a whole lot that we can do about that, though, because in this kitchen, I can't move the stove and I can't move the fridge. So those are kind of constraints in my process. But you notice if she starts out where she started before in the process, goes to the fridge, she should be able to pick up everything she needs for the whole meal from the fridge. Remember, I mentioned that we could store all of the breakfast items right there in a bin in the fridge. So I guess it would be the eggs and the butter and the salsa. I think those were the items that were in the fridge. There may have been something else, I can't remember. Those were the main things. But then over by the stove, if this is a meal that she cooks all the time, you could keep a bowl for doing mixing. You could keep the fork. I think the fork was already over there in that area. I mentioned keeping the pan for the eggs and the spatula and the spices together. I mentioned putting the toaster and the bread over there. And so you'll notice that if she goes back there and then she cooks the meal by starting out heating the pan and then mixing and putting the butter into the pan so that the butter melts so that she doesn't have to do the swirling action. And then she does the mixing of the eggs by putting the eggs in and the spices and then whisking them up all together and then putting it into the pan and then starting to make the toast and then finishing to make the eggs and then pulling out a plate and again having the plates over there by the stove so she can pull out the plates and then plate everything right there. Then she should have very minimal walking. And you can see there's still walking here. There's still waste. She's still going to have waste in her process. But you can see that the spaghetti diagram is much more streamlined. And this is the real power of a spaghetti diagram. Super, super simple tool, but really, really effective. All right, now back at the beginning of the class today, the very first video that we saw was of Mr. Bean painting a room, right? So the question is, well, what in his process was value added? What's value added? What was value added that he did? And if you need to, you can rewind back to that video. You should be able to pick out what's value added now. Okay, so the only thing value added, I guess there was a little bit of value added at the beginning when he was using his teddy bear as a paintbrush, but when the paint was actually going onto the wall. So the moment the paint was on the wall, the moment the paint was going onto the wall was value added. Okay, the dipping of the paintbrush in the paint can, the opening of the paint can, none of that's value added. Just the moment the paint goes on the wall, value added. Because the purpose of this process is to get paint on the wall, to transform the wall from the way it looks now to being a white wall. Yeah. And then the only other piece that was value added was once the firecracker exploded and the paint hit the wall, that was value added. Okay. Now all the wrapping of everything in the room and of course the unwrapping of all the stuff in the room that Mr. Bean's going to have to do and the repainting that Mr. Bean's going to have to do because the guy came in and blocked out part of the wall to get the hat, right? All of that's non-value added, but just the paint going on the wall was value added. So the key to improving processes then is determining what is value added and then trying to think, how can we reconfigure this process so I can do more of the value added? And I can do that value added slowly and I can do more of it, and I don't do as much of the non-value added waste. Let's see if we can find ways of getting rid of the non-value added waste. And when you do that, you can improve a process speed, you can get the delivery faster, and you can improve the quality simultaneously, both of those things at the same time. Okay? What we're going to do is we're going to look for waste. And we're trying to figure out ways to reduce the waste. We aren't messing with the value added, we're trying to reduce the waste, eliminate the waste. Okay, so next thing is to set initial goals for your process. Here are some benchmark goals, all right? So this is typical in lean organizations. First pass through, when you're improving a process, you set these goals. You need to have a target to look for. And I know that these sound like crazy goals. These are not crazy goals. The processes that we've seen today, the teams were able to improve these by 50, 60, 70%. So you set a goal for time of 50%. I want to reduce the time by 50%. And again, that's not by spending money. That's just by looking for free ways that we can reconfigure the process to eliminate waste. Reduce walking by 85%. And we're going to set these goals. And I'll encourage you, make the goals, especially if it's in a work team, make your goals something that people can remember. Like if you divide the time in half and it comes out to 12 minutes, 33 and a half seconds, like just set the goal as 10 minutes. Because the point of this exercise of process improvement is not to reach your goal. The point of the exercise is to improve the process. And believe me, like even if you made a 30% improvement on time, like you miss your goal by a big amount, like 30% would be huge, right? That'd be a huge win. So even if you don't make it's not about reaching the goal, it's about improving the process. So you're gonna set the goals and then you begin experimenting and you see what happens. Kind of like, should we whisk all this together or should we whisk one ingredient in at a time? I don't know. Let's try it and find out. Or are there certain ingredients that we can whisk in, but other ingredients that we shouldn't whisk in? Let's experiment. Let's cook it several different ways and see what works. Lean is all about experimenting and seeing what works and finding it out. That's what, honestly, a lot of these little improvements are. These are the restrictions that I will suggest for you on your first-time improvements. This is for business or personal, no cost or low cost. We don't want to go out and buy technology or buy an app or buy some machine to do the work for us. There's enough opportunity in our processes, non-value added, for us to find creative ways of getting rid of that stuff. We talked about pre-work, doing pre-work at the beginning. We talked about that last class session. We're not purchasing technology. And I already mentioned this, after improvement, total value added time should be about the same. All right, so I'm going to encourage you to do this, to start doing this. You know, as you encounter processes on a daily basis, things that you're doing that transform inputs into outputs, take a look and see if you can find the non-value added activities in them. Okay, and there's a variety of ways to do these. You know, all of you can do this in your kitchens as you're preparing meals. You know, look and see what it is that you're doing. Pay attention to what it is that you're doing. Look for when you're doing value added. Look for when you're doing non-value added. You know, you can use tools like taking video of yourself cooking a meal and watching that video, just like we've done here, looking for when there's non-value added. You can use a spaghetti diagram. And in fact, I'm going to ask you to do this for the next application assignment that is due. You're going to need to cook a meal, you know, cook a simple meal in your kitchen, cook a meal that you cook on a regular basis, and video yourself doing it. Use a spaghetti diagram there to look for the transportation that's involved, and then reconfigure how you have that kitchen arranged and how you do those processes to be able to improve those processes. So be taking a look at those things already, and you can look at that assignment as well that's posted on Blackboard. I also want to let you know, if any of you are working currently and you have a job and you know that there are processes where you can see waste, you know, maybe it's a process that's similar to the processes that we've looked at in today's class, and you say, you know what, I can see the waste in it. I don't know how to improve it, but I see that there's waste. Later on in the course, you're going to be required to actually improve a process and document that you've improved a process. And it could be a home process, but it might be a work process as well. And I want to let you know that if you've got a work process that you are interested in improving, I would love to help coach you through that. So feel free to reach out to me. I'll probably ask for a video of the process running so that I can see it. And I'll be glad to kind of help you, coach you through it, and coach you through the improvement so that you can experience making some really amazing improvements to processes as well. All right, thanks, and we'll see you next week.